Okay, it's live on YouTube. So now I'm going to send everybody a link. Send items.
Actually, is not presenting, right?
Yes. Okay. So here we go. So I need to go to
Kambule. Gabo Kambule.
Cambodia. Okay.
No. She's very nice. I like her.
Our microphone is live. Okay.
Johan Malherbe. Hey, Johan. En die geografie gebouw. Ja, dis precies, ja, precies daar gebouw. Nou, zie ik. Dit staan op die demonstratie. Dit is al oude.
Okay. Okay. Okay, let me just do this quickly. I'm almost done. Almost set. And finally, this one. And I need to resend. Oops. Okay. All right. So that's done. Now, let's see. Okay, I think we're good to go. I would like you to test something for me, Willem. And that is I'd like you to go to YouTube on your phone,
Okay.
which I'm going to set up for you now.
YouTube. I don't think I have a.
We'll just go to this link and tell me.
Are you sending me a link?
Yeah. Okay. All right. If you can test this. There, I've sent it to that WhatsApp. Okay. Just test to see that that's actually working.
Okay, I see your access thing.
You can see it. Okay, good. That's a good thing. If I move 20 seconds later, I should move. Have a look. It's got 20-second delay. Yes. It's actually working. Okay, great.
That's
remarkable.
Dance and see your dance.
No, I danced already. I saw it.
No, there it is.
Okay.
That sounds
all right.
Very clear.
Very good. That's good. So it's live on YouTube and it's on Zoom. That's good. Now, my next question is, can I pick on somebody that Tando, it's Celinda. Can you hear me? I just want to test that you can hear me. Tando Celinda, or the next person on my list is, oh, Kogi, you're there. Hi, Kogi. Kogi, can you hear me?
Hello, I can hear you clearly. Thank you.
Very good. Okay, good. And you can see the screen, right?
Yes, I can.
Perfect. So everything seems set up. All we need now is people. Okay, everything seems to be set up. All we need is people. And we still got some time. So you can go and get coffee. The YouTube is working. They've all been notified of the YouTube link. They've all got the WhatsApp link. Okay. 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 Right. My presentation is here, yours is here. I just want to check. I'm going to stop sharing for a minute, folks, just so that I can make sure that I've got everybody's presentations where they should be. Let's see here, Google Docs.
The title of my talk, woke. Very woke.
Hold on, let me just mute here. Morning, all of those that are online already. Just to tell you that we are scheduled to start at 9:30, which is still in 45 minutes, according to me. So there's time for coffee and everything else.
Thank you so much. Noted.
Just make sure that you are muted. Everybody must make sure that they are muted.
Never like an coffee black, bitter coffee. In my office.
Gaat nie goed nie.
Nee.
Okay, nee, ek moet nie sê nie wat ek wil hê nie. I'll take it.
That's all I can offer.
If you can find a student on the way, that would be great. If you can.
Yeah, I'll ask Sandro. Bring you a cup of coffee.
Thank you, thank you.
I would definitely not be able to get involved.
Okay, well, this, both is ideal, either is acceptable,
Okay.
neither is tolerable. Okay, let's see here. So we've got that going. Good. All right, I think we're set to rock and roll here. Let's just check. And I want to see if I go to the next slide, whether, and this is already wrong. Actually, I need to fix something. I need to fix something. And to do that, I need to go here, and I need to share the clip, copy that, and I need to go to here. No, I need to go to here, there. I need to change that to that. Okay. All right. There's somebody calling me. Hello. Morning. Fine, and you? Yes. Yes. It is building number 25 to the geology building. Yes. Okay, good. See you later. Ciao. Bye. Yes, let's save that. Take out that. Okay, all right, go back to here. Okay. There we are, close that. Share, right? Share that. Okay. All right, so again, everybody, you are nice and early. Thank you for coming. There are 33 of you online already. We're starting at 9:30. I've just put in a YouTube link in case anybody needs it, which we are also broadcasting on. So hopefully you will see it all on. Hi. 1 second. Just need to do.
Wannan da take rike kanwanta class ɗin ku ɗaya da ita.
Okay. Please make sure you are muted, everybody.
Kin ga har ta fi.
Uh, um, Peter Johnston. Pete, once you are online, please WhatsApp me so that I can make you a co-host. Thanks. Okay, so we are still waiting for time to start at 9:30. And everybody can hang out in the meantime. I hope you can see the title screen and you can hear me.
Yes, we can. We can confirm that we can see the title screen and we can hear you.
We have 53 participants online already. Please hang in, folks. We'll start at 9:30. We're still waiting for our locals to arrive. Folks, we are still scheduled to start at 9:30, so please hang in. Again, hello, everybody. There are 57 people who are online on Zoom, and 2 people on watching on YouTube, and we are scheduled to start at 9:30. So just hang in, please. Thank you. Hi, folks. See, numbers are slowly growing. We will be starting at 9:30.
Oh, no.
Okay, folks, we're starting at 9:30, hopefully, which is in 17 minutes.
Morning all, just making sure that my mic is working.
It is working.
Thank you very much. See you guys at 9:30.
Yep. Hello, everybody. Just hang in. We should be starting in about just over 10 minutes. Thank you. Okay, we're gonna start hopefully exactly at 9:30. We're still waiting for one of our opening speakers, who should be here shortly. Hi, folks. We're getting there. We are still a few minutes away. We hopefully will start on time. Yes.
Right.
Good morning, everybody. We are scheduled to start in 2 minutes. We have two opening speakers who are going to say some words of welcome. One is Serena Kutsia, the head of department, and the other is the acting executive from SOARS for climate and weather. It's Gabo Kambule. She's going to present her remarks online. So I just have to find her. So give me a minute so I can find her. And when she's online, she can speak. Meantime, Serena will appear shortly in front of you. I hope. There you are. Serena, you come here because you have to say hello to those people too. Okay. Yes. So we're going to start in 1 minute. We're just waiting for our acting exec online from, she was meant to be here, but she's going to be online from SOARS. So then we can go forward from there. So if you stand here, then everyone can see you.
Ah, cool.
Okay, so this is the head of department, and I'm going to try and say it because I can't say the word meteorology.
Well, as long as you can say geoinformatics, because that's our
Yeah.
voice full of.
And the first word is geography.
That's the easy one.
All right. So I'll give you the floor just to say hello to everybody. Thank you very much, Serena.
Okay, so very welcome here on this cold morning, and we are looking forward to having you here, and also to all of you who are online. How many people are online? Wow, that's quite a lot. Okay. And I see some familiar faces and I see some familiar names here. So some of you will know that we are the Department of Geography, Geoinformatics and Meteorology. It's the longest name, I think, in this university. So we do a lot of very diverse research going from geography, where we have human geography, to geoinformatics, which is technology, and then meteorology, it's very data focused. And what we're going to see today, of course, is very much related to meteorology, but it's equally applicable in geography, and I sometimes need the geoinformatics tools. So we're looking very forward to having you here, and thank you for Willem and Neville for organizing this and sharing this with the community, not only here, but also online. Thank you.
Thanks very much. Yes. Okay, good. And thanks very much to the department for hosting us today. It was complex to organize a hybrid meeting like this. So we've got, at the moment, about 30 or so people in the room, I'm guessing, and about 120 online. I don't know how many are watching on YouTube. So please just stick to the rules. Keep yourself muted. If you want to speak, please put up your hand, and I'll put the Padlet link in as well. I just want to check, is Gabo online? And if you are, I can't see Gabo from.
Yes, I'm
Yes,
here.
there you are. Hi, can you please
How are
proceed?
you?
You can unmute yourself. You are unmuted. You can put your
Yes.
video on if you want to, and the floor is yours. Thank you.
I'm not in a very good space, but it's okay. I will do the opening from here. Thank you so much, Neville. But
Breaking up. Gabo, it's breaking up. We can't hear what you're saying.
so that you can open this.
Neville, can I suggest that you turns off her video for better signal?
Yeah, Gabo, I think turn off your video, and you might get better connection.
Okay. Can you hear me, Neville?
Let's go. Yeah, I think so.
Fantastic. Thank you. All right. Thank you. Good morning, members. Thank you very much for, again, having organized this conference, all protocol observed. I'm Gabo Kambule. I'm standing in here on behalf of Dr. Mpepya. The devastating impacts of El Nino weather phenomena have been observed over the years, as exemplified by the 2015-2016 El Nino season, which was classified as one of the strongest El Ninos of this country. This event has detrimental socio-economic and environmental consequences, particularly affecting climate-sensitive sectors such as agriculture, water, and energy. Southern Africa in particular is a region prone to drought, with almost all countries in the area experiencing drought disasters, including Botswana, Lesotho, Madagascar, Malawi, Mauritius, Mozambique, Namibia, Swaziland, Zambia, and Zimbabwe. In South Africa, provinces like the Eastern Cape and Limpopo have also been impacted. Given the vulnerability of these regions, the world cannot afford to underestimate the devastating impacts associated with the El Nino phenomena. And South Africa in particular cannot afford to bear these consequences. The World Meteorological Organization on the 3rd of May 2023 released a new update indicating an increased likelihood of El Nino developing later this year. This development would have contrasting impacts on weather and climate patterns worldwide, and it's expected that it will contribute to higher global temperatures. According to the update, there is 60% chance of transitioning from ENSO neutral to El Nino during May-July 2023. This likelihood is projected to rise approximately 70% in June and August, and further increase to 80% between July and September. The assessment is based on inputs from World Meteorological Organization, global producing centers of long-range forecast and expert evaluation. The experts and research indicate that dry weather conditions are expected to persist in Southern Africa countries. According to the Food and Agriculture Organization, the return of El Nino in 2023 would have severe consequences for countries heavily reliant on agriculture, especially in regions already grappling with hunger and poverty. The FAO warns that with extreme weather events affecting food production, there is a heightened risk of disruptions to food supplies and significant price increase, which we have seen locally. The FAO Hunger Hotspots report stated that in 2022 alone, the number of people facing acute food insecurity was projected to reach up to 22 million in 53 countries, marking the highest level on record. The potential re-emergence of El Nino could exacerbate this situation, leading to further deterioration of food security and an increased risk of famine. In order to adequately prepare for the potential impacts of El Nino, it is crucial to foster active collaboration among all key stakeholders. This collaboration ensures the development of contingency plans for climate-sensitive sectors, and facilitates the provision of updated information regarding forecasts and potential impacts on vulnerable communities. Early warning and early action are components of this preparation. As the Weather Service, it is our responsibility, as mandated through SOurce Acts and its subsequent amendments, to work alongside our partners in communicating early warnings in order to mitigate the potential effects of the El Nino phenomenon. Our efforts align with the United Nations Early Warning for All initiatives, and unprecedented endeavor aimed at safeguarding people worldwide from hazardous weather, water, and climate events through life-saving early warning systems by the year 2027. SOurce, in collaboration with our partners, has therefore convened key stakeholders from academia, private sector, civil society, and government. Our strategy encompasses education, engagement with strategic partners and actors, as well as dissemination of focus and potential impacts. Today, we and our partners have organized the El Nino Summit, have organized the El Nino Summit, which serves as platform to freely share information, educate participants, and foster discussions on mitigation strategies that enhance the resilience of our communities and climate sensitive sectors. I therefore urge everyone to participate and be part of this solution. So with these few notes, I just want to welcome every member who has actually attended this summit. Thank you very much. I wish you an excellent deliberations on this day. Thank you very much, Mr. Neville.
Thank you. Thanks very much, Kabo. Just make sure I'm unmuted. Yes, thank you very much indeed for that. We're going to progress straight into the program. I hope you can all see that. You should have all received copies. I will introduce our panel of experts as we progress through the day. I'm going to say a few words now of context setting, and then thereafter, Professor Willem Landman will speak, and he's over there. And then from the South African Weather Service and Agricultural Research Council, Mokele Muletsi and Christine Engelbrecht will give you some inputs. And then we'll have some questions and answers and breaks for tea. So we have used a Padlet. I've given you the information for the Padlet. You can use the Padlet in this room, or you can raise your hand on Zoom and we will try and manage that. Or you can put your comments in the chat. Right, so let's go for it. Okay, we're going to talk about the story of the 2023 El Nino. What we will do then is talk generally about the history of ENSO, and Willem will give you a context about that. Then we will talk specifically around the history of ENSO in general in the country, and that's ENSO meaning El Nino and La Nina. And then we will, after tea, look specifically at the 2015-16 event, which was a very intense El Nino, and we will look at some of the impacts of that. And then we will, after lunch, look at what we know about this coming El Nino. What I will do is just give you a bit of context. And again, we appreciate that the group of people who are participating today is a mixed group. We have a number of scientists here who probably know everything we want to say better than we do. And among us are other people who are real human beings from normal society, as opposed to scientists. And people who are really interested in the impacts and understanding the processes. So if there's anything, there's no such thing as a silly question. If you have a question, please feel free to ask. And if we don't know answers, I'm sure members, experts in the audience will know. Okay, so I'm going to proceed to talk about what I want to talk about. First, I just wanted to say something about this grouping who kind of organized this meeting called the ECERA or ECERA. We haven't quite decided on a name. In essence, what it is, it's a group of researchers who have come together to look at extreme events. The subject of whether El Nino is an extreme event will be dealt with later. But in general, we are dealing with extreme events. And we know that there are extreme events associated with El Nino, and hence we called this meeting. And the whole idea of this group is to recognize that in South Africa, we've had a series of extreme events, and I want to talk about those. And so what we really want to do is say, what do we know? What do we understand about extreme climate events in particular, and their impact from the drivers all the way through to the impact, and especially around people who need information from science. The scientists ultimately need to develop outputs that are relevant. So what ECERA is doing is to bring together all people that are working across the board in this. And you will know, of course, that South Africa has had a lot of extreme climate events. And I just want to distinguish between the fact that an extreme event has a consequence, and the consequence might be a drought or a fire or a flood. That in itself is the impact of the climate event. So that is something to bear in mind. But of course, the way they're expressed is in all sorts of, and those are just some examples of what we've had in South Africa. But South Africa is not special in that regard. We are prone to certain kinds of extreme events, extreme climate events. But as you know, right now, as we're speaking, all over the news are the fires in Canada and the consequences of that. And I'm also reminded of the floods in Pakistan last year. These are really serious, large-scale events that are happening all over the world. The question really is, what does this all mean? And so I wanted to just, again, contextualize this by saying that extreme climate events are not unusual. They happen. They are natural. And they are in the background at a certain frequency. So there are things that do happen. And what they generally are expressions or exaggerations of what is normal climate variability. So we often have floods in the rainy season, or droughts when rain fails in the rainy season, or fires in the windy season, for example. So what happens is we get exaggerations due to a whole range of different climatic conditions. And so extreme climate events are effectively weather events that lead to these impacts, as I was saying earlier. And extreme events are not caused by climate change. This is very important to appreciate. They are not caused, as I say, they are natural, they do occur, but they're not caused by climate change. However, climate change is resulting in an increased frequency and intensity of these extreme events. And so in a sense, we see climate change manifesting and expressed in increased frequency and intensity and that's really where we need to focus. So when we want to feel the impact of climate change, this is where we'll find it. And this is from the IPCC, which shows, it's really a sort of a cartoon to describe for heat at the top left and for heavy precipitation. You can sort of vaguely see the world's map in this. You'll see the Southern African region down here, ESAF, Eastern Southern Africa and Western Southern Africa. And these are estimates of the rate of increase of and the intensity of extreme events, which were produced in the chapter on extreme events in the last IPCC report, showing that indeed there is evidence to show that the rate at which extreme events occur, the frequency and the intensity is increasing in Southern Africa. So we know this is happening as a consequence of climate drivers. And what I put up here is a really interesting bit of data that comes from the World Economic Forum. What they've done is they've tried to assess what risk there is to development and to economies from different things. And there are two columns here. One is the 2-year column, the other one is the 10-year column. And this is the result of this assessment of a whole variety of experts. And interestingly, in the 2-year time frame, the one challenge that is most serious is in fact the cost of living one. Second comes natural disasters and extreme weather events and so on. So the green are all environmental. And interestingly, in 10 years, the top 4 threats assessed by the World Economic Forum are all from climate. Failure to mitigate climate change, failure of climate change adaptation, natural disasters and extreme weather events, biodiversity loss and collapse make the top 4. Interestingly, if you'd done this survey before the Ukraine-Russia war, you would have seen that all the green would have been at the top. But subsequent to that, the cost of living, they call it geo-economic confrontation, have in fact replaced those as an immediate threat to development and economies. But just to make the point that this is a real problem to our economies. Then I'm going to just spend a little bit of time on some theory, and then I'll show you the practice of this theory. This is from a paper published in 2018, and whenever I give a talk, I use this. Apologies to those who've seen it many times. So this green line represents a normal seasonal signal. So it's summer, winter, it could be rain, it could be temperature, and it's a noisy signal. Some summers are hotter than others, some are shorter than others, and so on and so forth. But it's a regular signal. As I said, extreme events happen with a particular frequency. They are a particular conflagration of climate conditions that result in extreme events, and they happen with a certain periodicity. So that's natural and normal. But then on top of that, we've got a baseline change, an average change in some of these conditions, and that's the climate change signal. Now, if you combine those three together, so you've got your normal seasons, you've got your extreme events, and you've got a changing baseline. If you put them together, you get this black line. So in the black line, you can still see the seasons, and you can see the extreme events superimposed on those, but you can also see the trend. And what that does is it creates, if you like, a new platform for those extreme events to take us into new records. And so the consequences are, if you get into this yellow area, that you can have an extreme event and you can recover from it. But if it happens too frequently or too intensely, you get into a position where there's permanent impact. That's what this paper is about. So this is important to bear in mind, because extreme events that happen on top of change have bigger impact. So this is the context. Now I'm going to whip through a couple of quick slides. The context of this year's event. So what you're looking at here is what we call the skin temperature of the ocean, the sea surface temperature. The middle line is the average, the long-term average for, I forget how many years it is, from 1981 to 2000 to 2022. In fact, I think that the long-term average is a longer one. And the two lines on top and below are two standard deviations, a statistical measure of variation. So that's what the average world sea surface temperature looks like between 60 south and 60 north. I don't know if you can see it well, but there's a gray line at the bottom. I just did it for reference. That's 1982 when this record starts. So that's a kind of reference point of what 1982 looked like relative to the average. Then this is the El Nino of 2015-16, and you can see that that year was warmer than 2 times the standard deviation, and that is 2016. So you can see it started in that year. Just bear that in mind for later, what it looks like relative. So you can see it was hotter than 2 times the standard deviation, warmer, the sea surface temperature. Those are the 2 years together. That's 2022, the yellow line. So you can see what 2022 looked like. That's last year. Here I've put on the last 10 years. So you can see the reference point 82, and then you can see how, in general, the oceans have been warming. The sea surface temperature of the oceans have been warming over the last 10 years, with 2022 highlighted. 2015 and 16, you can see how high they were, okay? This is 2023. 2023 has got, especially for the months of May and June, have got sea surface temperatures that are higher than have ever been recorded in this time series. So we are starting with a new platform. That this might be an expression of the El Nino itself, but we are seeing sea surface temperatures that have never been seen before in the month of June. So that's a real worry. What the consequences are, we will find out shortly. I think I've put on the other years for that purpose. And then yesterday, it was announced that although it's not the hottest temperatures for a summer, but for a June month, this is the world average temperatures for June, is already higher than ever recorded. So the heat, the temperatures of the Earth's June is warmer than has ever been recorded in this record so far. So this goes back to that theoretical point that we're seeing those pushing ourselves into new territory. Okay, so then this brings me to the purpose of this workshop. And I want to stress, we are not here to alarm anybody, but we are here to alert you. That's what we want to do. And we want to raise awareness. So this is not, doom and gloom. We certainly have enough bad news. So that's not our goal here. But we do want to make sure that as this develops, and we don't know yet what the outcome will be, people need to be alert to it and aware of it. That's one point. The second is you don't want to create panic. Nobody needs to panic yet, but we do need to be prepared, because forewarned is forearmed. So we do need to understand, and that's really what we want to do. So we want to share information, and then vitally for us is to learn from members of society, people in our society who are concerned about this and the impact on their lives. And that's really what we want to try to achieve. Okay, so that brings me to the end of what I wanted to say. We're going to move on to our next presentation. Let's see how we're doing for time. Yep, we're on time still. So next will be Professor Landman, who will talk to you about ENSO in general. But before we do that, let's just see. I see there are a couple of comments and questions. So let's start with the floor. Let's just see if there are any questions or comments from the floor inside the room here about anything that has been said thus far. Anybody? Comments, questions, please?
Given my opinion, I'm just wondering, you've got 40 years that you're comparing against it. Has there been a track of those parts of temperatures going back further using, I don't know, that they've driven to ice cores and that kind of stuff? Where are we sitting now in comparison to 100, 200, 300, 400 years ago?
Yeah.
Or even 1,000 years ago?
Yeah.
This type of thing happened before.
So the question is really about the overall rise relative to this 40-year band of data. Do we have better data or older data or longer time series to compare? Does anybody else want to answer that question? Anybody in the room want to answer the question? Okay. Well, again, the answer is absolutely. We are in uncharted territories with regard to long-term time series. There are records that Earth was a lot warmer in geological time periods than it is now. But since the last glacial period, we are in an era of much warmer temperatures than before. There are lots of different databases and different records that have different kinds of resolutions. Here we have real observations, almost daily observations. Some of those are their resolution is difficult to compare them to. But there's no question about that. I mean, that's a question about whether the Earth is warming. I can bring 1,000 resources to show you that it is. But the answer is certainly yes. We are warmer than we have any record of. But especially in the last 40 years, we have never been in this territory. Any other comments or questions? I just want to quickly look and see. I agree we should not alarm, but we should create awareness. Please repeat the audience questions. I did that. Okay. Society does not listen to scientists. Well, okay, let's see. I'm just trying to see if there are any other comments or questions from the floor. Okay, right. I think that's it. Any more comments or questions? Everyone understood where we're going? Right, great. Then I'm going to ask Willem to please come and take the floor while I'm just going to stop sharing while I swap over presentations. You can come up in the meantime. To do that, I need to close that and I need to open another one. Just a second. It is what is it? That's the one. Okay. I'm going to do that. All right. And I'm going to, I need to share the screen again. Oops. That's a mistake. Okay. All right. Willem, you have to stand here so people can see you and hear you. All right. I think that's it. Thanks.
Okay, good morning, everybody. And thank you for coming. Also to those who are attending online. This talk will not be showing any expectation of what will happen over the next couple of months. This is just to give you an informed piece of information about what El Nino and La Nina, which is something we're not going to be talking about much, what those things are. So this is just to educate you. Okay. So if you know already a lot about El Nino and La Nina, you might find this extremely boring. Like, so now's the time to catch up on WhatsApps and what have you. So I'm calling this El Nino, but I'll be talking a lot about La Nina and where's the change of the
You need to just push that one. No, wait, you don't. Okay, then you have to click there.
Okay, thank you. So I've written there in red at the top because this is rather important to realize that we are dealing here with three phases when we're talking about Enzo. And the name Enzo is already a bit confusing because it doesn't have La Nina in it. It's Enzo stands for the El Nino Southern Oscillation, but it is supposed to cover three phases of what's actually happening in the equatorial Pacific Ocean. This is important to realize that El Nino is something, or La Nina, or the neutral phase, is something that happens in the Pacific Ocean. So a farmer would typically ask me, well, you said there's going to be an El Nino, but there wasn't an El Nino because my farm received good rain. Because that doesn't mean that when there's an El Nino, the word doesn't mean dry over South Africa. We'll get to that a little bit later on. But here I'm trying to show what the different phases are supposed to show in terms of sea temperatures and deep convective patterns. So if you look at the situation where we have a kind of a normal year, which is this middle bit here, you see the red area, this is Australia, this is South America. You see that the red area that is supposed to represent high temperatures. And by the way, the temperatures there, when you see red, it's typically in excess of 32 degrees Celsius. It's amazing to think that sea temperatures can get that warm. And associated with these warm sea temperatures, we have deep convective patterns. And as you will see on the next slide, how that may influence global circulation patterns. Anyway, when we have an El Nino, we have a much broader warming of the Central Pacific Ocean, and also a shift of the convective patterns towards the east, as you will see over here. This is for the stick.
You can use your mouse.
Oh, okay. Let me use the mouse. Okay, thank you. Okay, so can you see you see the mouse on there? Not really. No, okay. Okay, I'm gonna have to. Okay, so what I'm trying to show you is that we have this is for the midsummer season of December, January, February, and this is for autumn. So the bottom row represents autumn and the top row represents midsummer. But they more or less show the same idea of during El Nino events that you have a basin-wide warming and an associated shift of these deep convective patterns. So this was just for.
After the slides.
No, please.
Okay.
Okay, thank you. So the previous slide just showed this little area of it's a massive area, in fact, over the Central Pacific Ocean. But what I'm showing here is a global representation of the shift of the so-called Walker circulation. And this Walker circulation, as you may see from this slide, is still very much restricted to the tropics. But the important thing is, as a consequence of the warming of the sea temperatures, as a consequence of the warming of the sea temperatures, we see how the deep convective patterns are shifted. And that's the important thing. That we'll talk a little bit later on. Here I have a little diagram. Of course, I have to give acknowledgement to the source. And I also highly recommend that you actually subscribe to climate.gov. They send you emails every week or so with some very interesting information about climate in general. It's of course very North American centric, but there's a lot of other information that may be useful to know. So this is a very interesting graph or a diagram that they recommend we follow in order to know whether or not there's an El Nino coming. And so I'm not going to go into too much detail other than saying the first thing they ask is the sea temperature is warm enough? Is it above a certain threshold? And then very importantly, how is the atmosphere responding? Do we see in the observations what this diagram is suggesting how things should change? So the reason why I'm mentioning this is that we should realize that this El Nino and La Nina and the neutral phase, the condition, the three phases of Enzo, is very much an ocean atmosphere coupled system. It is not just one or the other. Those two things have to be working in unison. So that's important as part of the way to understand the dynamics of what happens in the Central Pacific Ocean. Oh, okay, sure. Sorry to process. Thank you. So here we have two sets, and the previous slides concentrated almost entirely on what happens over that equatorial band. So what we are in the subtropics. Okay, so the next slide here shows how we have experienced the impact of El Nino and La Nina events. And these two maps come from earlier work done in the 1980s. This is actually when the early 80s, this is actually when we started to realize El Nino and La Nina events affect global circulation. So for those of us who are slightly not so young anymore, 1980s, it sounds like really recent, isn't it? So prior to the 1980s, we didn't really know what the hell's going on. So if you compare this science or seasonal forecasting that I will come to a bit later on, it's actually fairly new compared to something like weather forecasting. Weather forecasting has been going on for much longer. But the realization that we can say something about the season based on El Nino and La Nina is a fairly recent development. This is the map, the two maps that they were published in papers in the 1980s. Ropoleski and Alpert, you can read those guys, about those guys, and they actually have retired already, so a long time ago. And here's a much more recent representation of what we know El Nino and La Nina's influences are globally. But the bottom line for us here in Southern Africa is that when we have an El Nino, we tend to experience dry conditions. When we have a La Nina, we tend to experience wet conditions. And we've had 3 consecutive La Nina events the past 3 seasons, and we've had quite a lot of rain. So normally when we have La Nina, we have lots of rain. But now, El Nino, this diagram, this new map, and the old one, they are in agreement that when we have an El Nino, drought is going to happen. Okay, but is it so simple? Is it so simple to make a forecast? El Nino dry, La Nina wet. Let's see how this plans out. Okay. So why was it so important for us to know something about Enzo? And I have alluded to that already. It's because of the fact that we have an Enzo that has enabled us to make a forecast. I've just actually kind of already made a forecast in the previous slide, because that map says El Nino means drought. So that's a kind of a forecast already, right? So on this time scale of months ahead, we cannot really say something about frontal movement or tropical cloud band or thunderstorms, something like that, that we normally have the capability to say about this on a weather timescale. When you listen to a forecast on the radio or television, typically would say, it seems like it's going to be a cool morning and we're going to have thunderstorms in the late afternoon. And tomorrow morning is going to be clear skies. We can't have that kind of forecast on seasonal timescales. We would at best be able to say there's an increased likelihood that we may see wetter than average conditions over a long period of a couple of months. So the detail that goes into the statement about what might happen in a season is quite a bit different to weather forecast. But because of this, El Nino and La Nina events that we've seen, and that will still happen in the future. Because of this, we can actually start to make forecasts. And then we get to the stage where we are forearming those people by forewarning them. Okay. Right, so now, how good are we at using the information that comes from the Pacific Ocean? This is a verification statistic. And I'll explain to you what this is all about. This so-called rock score, and forget that name immediately. That score is supposed to tell you whether or not your forecasts can discriminate wet seasons from the rest of the seasons, or dry seasons from the rest of the seasons. That's one of the very first things that you have to see about your forecast system. Does it have that attribute? Because if it cannot differentiate wet from the rest or dry from the rest, then what's the sense of trying to make a forecast? Because that's the first thing we check. And so we have tested this over a long period of time using an ensemble of models, very different models coming together, making forecasts for Southern Africa. And here we see our capability in predicting wet as represented by the black bars, and our ability to predict drought as represented by the white bars. Here are for El Nino events, La Nina events, and exoneutral events. And so what we see already is that we have a capability of predicting those seasons when there's an El Nino where it was not really being that dry. This is what this graph is telling us. But we have much more skill in predicting droughts associated with El Nino. With La Nina, we see higher skill. And this is something that we'll also touch upon later in this talk, is that we are much better able to predict the season when there's a La Nina. We are getting towards an El Nino, which is a bit unfortunate. We should actually have this type of meeting when we have a La Nina. Because we are very good at predicting the outcomes during La Nina seasons. It's always when we have El Nino seasons, we're not so sure about the forecast. But the important part of this slide here is when we are trying to predict the rain of the coming season, when there's neither an El Nino nor La Nina, we are really terrible. So this is often something that the people get confused about. They say, oh, there's neither an El Nino nor a La Nina, so that means we're going to get a normal season. It doesn't happen like that. It actually says, when there's neither an El Nino nor a La Nina, it's best to ignore a forecast. Base your decisions on anything other than a forecast, because the forecast is very likely to be very misleading. That's why it's so important that we do proper verification work to tell us these things. We have seen two things here. We are able to say something about the rain during these phases of El Nino and La Nina. We are more able to say something about what might happen during La Nina, but when there's nothing going on, don't get it right. We rather should keep quiet. We definitely won't have a summit when there's a neutral season. This is a time series of sea temperature anomalies over a long period of time, as recorded over this rectangular box here, which is called the Nino 3.4 area. Traditionally, we only had the Nino 1 and 2, which is just off the coast of Peru, and Nino 3, the red box, and the Nino 4, the yellow box. But this Nino 3.4 is a special kind of box for two reasons, I think. First reason is because that box, sea temperatures, best represents what happens in terms of El Nino and La Nina events in the Central Pacific Ocean. Also, this box and its associated sea temperatures is best associated with South African phenomenon. So we have a special interest in the Nino 3.4 area sea temperatures. So here we have the different classifications from very strong El Nino events to very strong La Nina events. And they all look different. Not a single one is exactly the same as the ones before. So the way that this particular phenomenon develops is different from one year to the next. So then it is obvious to also realize that its impact over the areas where it has an impact will change from one year to the other. Not every El Nino year is the same. Not every impact of El Nino over Southern Africa is the same. And I'll show a few examples of that. And that makes the forecast problem a bit more challenging because there are very few analogs. In fact, there are none, I think. Oh no. Okay, so this slide is just to make the talk a bit more complete. We're talking mostly about El Nino and La Nina here, and specifically about El Nino. And so obviously there are other things that may also influence our seasonal to interannual variations, such as the subtropical Indian Ocean dipole and the Indian Ocean dipole, which some of the scientists, atmospheric scientists in South Africa have shown that this has an impact on our variations and from season to season. But my own experience from talking from a operational perspective is the models don't really care too much about what happens here. It's the main driver for operational forecasting comes from what happens in that Pacific Ocean. We have done some tests to test whether or not we shouldn't just only look at Pacific Ocean SST. And we have found that if you look at the global picture, we find slight improvements in skill. So that means that somehow the models do incorporate these, but they seem to be playing a much lesser role as what we see what happens from the Pacific Ocean force. That's a very important part. Now, this is a very complicated slide. This is actually quite from a fun experiment that we did, because we realized that the signal from ENSO, as what we have seen in the literature, is supposed to come through the Indian Ocean, and it's not always that obvious how that happens. And so we did an interesting experiment here. We thought, like, let's think about the ENSO signal reaching Southern Africa through the mid-latitudes. One of the ways that we started with this is to consider the rainfall over Southeast South America, Uruguay, Paraguay, southern parts of Brazil, and parts of Argentina as well. Let's see how that rain, which should normally has its strongest association with ENSO during our spring, September, October, November, how that relates to our rainfall peak, December, January, February. And what this slide tells you, I'm not going to go into much detail, that if we use the rainfall recorded over South America, we are producing a better forecast than what we get from models. So that means that there may be something that the models keep on missing, and that missing link may be in this mid-latitude description. And so what we've done here in this experiment is to see, okay, the forecast that we see from this international center, the International Research Institute for Climate and Society, for South America is to be dry. And we know what the rainfall looks like when it's dry over there. So let's use that as a predictor of our rainfall. We made a forecast for the season that we just had. We show enhanced probabilities of a wet midsummer. What happened? We had a wet midsummer. So the reason why I'm showing you this is to show that there's still a lot of research that has to go into the full understanding of the dynamics. We have been doing this seasonal forecasting business now in South Africa since the early 1990s. And still we have many questions that remain unanswered. And so we are still, or even though we make the forecast, we are still improving on our understanding. But this shows that there may be some mid-latitude contribution and something to this southern annular mode. And we have a southern annular mode expert right there at the back who will be able to answer questions related to that particular phenomenon. But the point is here that we show that there's some more work to be done to try to improve on the forecasts on this particular timescale. Here we have on the left a forecast for the midsummer season from two different modeling configurations as represented by these thin lines. And the thick line is showing the observation. This is for an area south of about 15 degrees south. So it's a larger SADC area. What I'd like to point out is how many times we've seen very dry seasons associated with E. And guess what E stands for? El Nino. Here we have many wet seasons associated with L. Guess what L stands for? La Nina. But we have here a wet El Nino. And here we have very strong anomalies predicted by these very complicated, highly sophisticated forecasting systems. In 97, 98 will be a devastating drought. And it wasn't even close. So this graph shows two things. We are actually not doing such a bad job. The correlation is quite nice, 0.6 for this time scale is fantastic, to be honest. But there are certain years that we will miss. And sometimes we make a big miss. So there's a lot of uncertainty in the forecast. Here's a rainfall that I measured at my house. As we've seen here, when we are talking about extreme droughts, I'm not talking about forecasts, I'm actually talking about observed droughts. They are associated with El Nino. So even though we have El Nino seasons that are not dry, when we've had extreme drought, almost always, there's a few exceptions like 81, 82, when we have had extreme droughts, it's almost always El Nino. So although there are some uncertainties regarding the forecast, there's no doubt that when we have an El Nino, we should actually have a summer, which is what we are having one now. Okay. Okay, this is a very complicated graph. Okay, so I'm not going to go into much detail. But what this graph is to represent is how reliable are our forecasts. And I've mentioned in a few previous slides that we have uncertainties associated with the forecast. And that also dictates that we have to issue forecasts for rainfall and temperature changes over the next couple of months in a probabilistic way. And so we cannot make deterministic forecasts to say this season will be dry. Cannot say that. There's very little skill in that. But there's some skill in giving some direction which we expect the rainfall outcome to be and the confidence associated with that statement. If we want to see those statements that we make that have associated with them some measure of probability are reliable, we have to see if the probabilities with which we have issued these forecasts match the frequencies at which they happen. So if we say there's a 60% chance of it being dry, it has to have happened 60% of the time in the past. And what we see here is a representation of how reliable our forecasts for wet seasons are compared to how reliable our forecasts for dry seasons. Without going too much into any detail, you should all be able to see this thin blue line as well as this thin red line. What we want to see is these thin lines to fall exactly on this diagonal line to represent perfect reliability. We see that the blue line is not too far away from that. So this again comes back to the statement that I made before that we are actually not doing such a bad job predicting wet seasons. But our forecasts for droughts are often overconfident. Let me give you an example. We could say there's a 60% chance of it being drought, but it actually happens only about 30% of the time. This is because these models that we use seem to dance to the tune of Enzo. When there's an El Nino, the forecasts tend to make it dry over us. And we've seen in the previous slide that sometimes when we have El Nino, we don't have drought. So El Nino doesn't mean drought. But for the most part, it does mean drought. And now to summarize my talk, this is obviously then the last slide. There's a message there, allow recordings. Okay. Okay. So the summary, a few bullet points. ENSO is something that happens over the Pacific Ocean. It's not a drought on somebody's farm. It has global impacts. And because of this, we are able to make forecasts. We have seen that each event is different from the other. Over Southern Africa, that for the most part, if there's neither an El Nino nor a La Nina, you can't actually make a forecast. We're also much better in predicting wet conditions associated with La Nina as we are in predicting drought associated with El Nino. Other phenomena are also important, and this is where we really need to trust the models that we use, that actually, so that we should believe them, that they actually incorporate these other features in the climate. When we've seen extreme droughts, it happens during El Nino. Unfortunately, when we're talking about forecasts, we often find, this is what the verification tells us, we are often too confident in making drought predictions, especially during El Nino seasons. The talk I'm giving you this afternoon will be mostly about forecasts. So I'll show the evolution of the forecast of El Nino this season. And I'll end the talk by sticking my neck out to try to at least say something about the coming spring. But at the moment, we're not brave enough yet to make the forecast for the coming summer. Sorry? Yeah. Yeah, we're still a long way away. So if there are any questions, I think.
Okay, thanks very much for them. Thank you. I'm going to look at questions and open the floor now. I want to just interview you quickly just to make sure. So firstly, I want to make sure that so ENSO and includes La Nina and El Nino, that's the general term. It's the sloshing around of water around the Pacific, different temperatures, different thermoclimes, has this global effect. Does it affect all of South Africa or just the sub-rainfall area?
Okay, it has a very weak impact over the Southwestern Cape. Not so strong. The Southwestern Cape prediction capabilities is not as well advanced as the prediction capabilities over the summer rainfall region because of the weaker influence from ENSO over that particular area.
So mostly in the summer rainfall area.
Yeah.
And just to emphasize a point you made is that most droughts that we have in the summer rainfall area means failure of summer rain, right? And so when we say drier, we mean drier than what is an average for summer, right?
We don't have a summer where it doesn't rain at all. It's just not enough.
Right. Okay. So a wetter, when we say wetter and when we say drier, we mean than average in the summer rainfall area. Because of course the Western Cape has a dry summer anyway, right? So that's one other thing. It also affects temperatures, but I think we'll hear more about that just now, about temperatures. And then again, to emphasize the point that this is not a fixed relationship, it's influenced by a whole lot of other factors, which explains why sometimes this relationship doesn't work, right? So that's what's important.
Yeah, and another unfortunate thing is that we have a limited number of cases. Now, if you're looking at weather forecasting, they do this a couple of times each day. We do this a few times a year for the past 40 years. So we have much smaller sample size to work with.
Right. Okay, good. Are there any other questions from the floor? There's a whole lot of questions online. Please go ahead. I'll take 2 questions from the floor, and then I'll try and sample some from the internet. Whatever it's called.
It's difficult to do a prediction of, if we're going to have an El Nino event to actually say that there's definitely going to be a drought. How strong is the predictability that it is going to be an El Nino event, and how far in advance can we predict that, and can we predict how long it's going to last?
Very good question. So we are much better.
Can you just quickly repeat the question and then?
So he's actually asking if we have the capability to predict something about what happens in the Central Pacific Ocean, more so than we are able to predict something about what happens over us. We are much more able to predict what happens in the Central Pacific Ocean. We have that Central Pacific Ocean area, that Nino 3.4 area on this timescale is the most predictable part of the planet. It's so predictable that we can even predict whether or not there's going to be a neutral season. As I've shown in this talk, we are not able to really predict neutral or normal rainfall seasons here. But we can say something about whether or not there's going to be a neutral situation in the Central Pacific Ocean. And we can do this months ahead of time. I'll show this afternoon that even in my January forecasts, I started to suggest the situation of an El Nino developing. That is a bit risky. For the most part, we should first go at least enter the so-called autumn barrier, which is normally March, April, thereabouts. Once we get into winter, our forecasts of ENSO becomes much more skillful, but we are still terrible in trying to predict what the rainfall might be as a consequence of ENSO that we're predicting.
So just let me reiterate this for everybody, because this is really important, I think. So we can predict El Nino more than we can predict the impact of El Nino, right?
Especially over us.
So we know that there's an association, and as you pointed out, 2015-16 was one of the strongest El Ninos, the biggest signals on record, and had a big impact on Southern Africa. Whereas, which was it? 89. Which one was the one that was very deep but didn't have impact?
97, 98.
97, 98 was an equally strong, almost as strong El Nino, and had no impact on our rainfall. Don't know about temperature, but had no impact on our rainfall was quite normal. And then the other point is that when there is no signal, neutral signal, which is one of the normal states, that again, we can say, well, there's no El Nino or La Nina, but that means that we can't tell you whether we're going to have a wet or dry season. So, or the likelihood is lower that we can predict.
We can always guess.
I just want to mention somebody asked the question about what skill is, and skill, as I understand it, is really the reliability, a measure of the reliability of the forecast.
Yeah, well, there's so many different aspects of skill calculation. There's very different range of different attributes that we have to check. But the bottom line is, if a forecast system have been tested over a 30-year period, and if the correlation between the forecast and observed is something like 0.6 or 0.7, it's actually a skillful model. So to say something, to define skill in a single sentence is very challenging. It's a range of attributes that we have to look at. But the bottom line is, are the forecasts correct?
Yeah. Okay. Good. Oh, sorry, you did. I have your hand up. I apologize. Please go ahead.
Have you ever thought of linking that to the potential invasiveness of places?
Oh no, sorry, not me. I'm sure there's others, but no, not me personally.
Because we're now talking about parasitic elements, we're talking about invasive potentials, and we're talking about certain species that are going to take over the world, etc. But no one's actually looked at how you could use your predictive models and the sort of climate change predictive models and the invasive species predictive models together and see how we can come up with a problem.
It's a good research question. Emma's got an answer.
I don't get it myself, but there are a lot of people who do invasive species models, the long-term climate change predictions.
Sorry, I'll repeat the question, Peter.
It's not my cabbage patch, but there is. I think that's
So the question is really about the relationship between ENSO and invasive species. Yeah, I think it's an important research question. I don't know if we have anyone here who can really directly answer your question, but certainly it's something which see it in someone's head. Okay. I just want to ask, I just want to relay one other point here. Anthony Forbes has written here, so we do not really know how to extrapolate, is it say ROM or from, it must be, extrapolate from the Central Pacific to South Africa. Now, much of that question is asking about what you were talking about, the mechanism that explains why when we have this phenomenon in the Pacific, we have a reaction to our climate, the actual mechanism, or whether he means we just don't know what we're doing.
Yeah, so the general theory is that there's a strong part to be played by the ocean surrounding us, which is something that we have actually found. But we have neglected that up to this point to much more in detail study how the mid-latitudes is affecting the seasonal variation as a consequence of enzyme.
So, I mean, sorry, go ahead.
Yeah, so we believe that this is some of the work that we've done for shorter timescales as well. And even if you are a weather forecaster, you are very interested to see what happens in the mid-latitudes, even the summer rainfall predictions. And so we are looking into this notion of how important the westerlies are in explaining what ENSO's impact on Southern Africa are.
So, okay, so we'll have to move on now, but thanks for it. But I think the message is that there is this relationship. We can do some forecasting. We have some confidence in certain seasons more than others. There's an enormous amount of uncertainty, but we have seen examples of exactly what can happen.
Having said that, we have much more certainty about statements for the coming season that we had in the 1980s. We didn't know what the hell was going on. In the beginning of the 80s, we said, take your pick, guess, we don't know. There's an equal chance of anything happening. At least we are starting, well, we have been doing this now for quite a while. We are able to see what the direction is of this coming season. Is it more towards dry or more towards wet? That we have actually been able to do quite well.
I just want to quickly highlight two important questions here. One was about the impact of tropical rainfall input and cyclones. This is bearing on northern KZN. So I guess this would be a relationship between La Nina and KZN.
Yeah,
And then there's something on the big weather, which I'll answer.
Okay, so when there's a La Nina, the chance of tropical cyclones making landfall over Southern Africa is increased. And this is something we see also in the rainfall that we observe over the Lowveld area. So it's a strong La Nina signal as a consequence of the tropical cyclones tracks having more landfall episodes over us.
Okay, and then there was something about the Benguela, and I don't want to confuse the issue. You do get some similar phenomena of changes to state in our oceans, mostly along the west coast. And there's something which we call, named after the La Nina, called the Benguela Nino, when warm water comes down in from Angola into Namibia, and that does affect fisheries. And interestingly, it affects species. We sometimes see species which are not normal in Namibia having come with the water. Now, I'm not sure that that's precisely the same mechanism or comparable mechanisms. But we're going to stop. Thank you very much, Willem. We're going to move on because we are heading for tea at 11. But before that, we have asked Mokele and Christine to give us some input from their perspective on general impacts around on agriculture and on temperature in Southern Africa. So, Mokele, are you going to go first? Where are you? There you are. Let me see. Have you got a? Okay, so let me just quickly load this talk. Okay. Do you want Christine to go first? I don't mind. Christine, are you ready to go first? Okay, good. Then you come along. I'll load this afterwards. Just a second. Bear with me, everybody, while I load Christine's talk. And to do that, I need to go to the El Nino Summit, and I need to go to the presentations, and I need to go to this one. It's this one now.
Yes.
Okay. So this is Christine Engelbrecht from the South African Weather Service. I need to share the screen. Hold on. share the screen. So go like that and go to screen 2 and share. And I believe the floor is yours and everyone can see it.
Thanks, Neville. And is
You
it
have to
just
speak
this?
into that. Oh, so
Yeah.
you have to click on that thing,
Ah, okay,
on that thing there to make it change.
okay.
Good.
Okay, so in this talk about the history of Enzo in Southern Africa, and then specifically looking on the observed temperature conditions. Actually, I bargained to follow on the ARC talk, where specific El Nino events were selected by Johan and Mogele from the ARC to zoom on into the rainfall response during those specific Enzo events, El Nino events. So I'm going to look at the similar ones, exactly the same ones actually, and give you an overview of the observed temperature anomalies and heat wave occurrences during those El Nino events. So on this graph here, similar to one that Willem has shown previously on the state of the sea surface temperature anomalies in the what is referred to as the Nino 3.4 region, which has been shown to be associated with the climate during our summer season over Africa. So the El Nino events that are going to be briefly looked at are indicated by the arrows. So the darker the red arrow, so these 3 dark arrows you see here are the very strong El Nino events of the 1982-83 summer season. Then the middle one here is the 97-98 summer season, and then the one on the far right, the well-known 2015-16 summer season. Then just to highlight also here the 91-92 summer season. I'm not sure whether you can see. Oh, you don't see it. Sorry, I need to use this. Let me just see. Okay, yeah. Yeah, okay. So just going to quickly show again the very strong El Nino events. This one here, that one there, 97-98 season, and here the 2015-16 season in terms of the temperature anomalies over the Nino 3.4 region. Then the 91-92 El Nino event was classified as a strong El Nino event. Then these in this funny yellowish colors, moderate events, and this bright yellow colors were when weak El Nino events were present. Okay, so on the next slide, we are looking at the temperature anomalies, and this is now maximum temperature anomalies, and this is for 9 stations of the South African Weather Service, starting from the 1970-71 summer season up till the 2015-16 summer season. And for each season, you will notice 2 bars. Let's just use here the last season, the 2015-16 season as an example, with a darker bar, the October to March summer period, and the lighter bar, the midsummer period, the December, January, February season. Again, these are the El Nino events in question or under investigation. So just to show you, for the very strong events, the 1982-83 event, for the average maximum temperature anomaly for those 9 stations can be seen here. Important to notice maybe is that considering the whole season versus the midsummer period had the largest temperature anomaly. This is also true for the 90. Let's move to the other very strong season, the 97-98 season, as was mentioned in Willem's talk, that in terms of the rainfall response didn't materialize in the widespread expected drier or anomalously dry conditions. So here you can see for those 9 stations, basically just average, not really any big temperature anomaly. And then here for the 2015-16 season, quite a large temperature anomaly. just to highlight the 91-92 season, which was a strong El Nino event. There again, also the December, January, February period, quite a large temperature anomaly. Okay, so then for the moderate seasons, it basically can range, mostly quite warm, but then yeah, for the 10-11 season, again the temperature anomaly not that large, and then just for an example, here for a week event, quite a large temperature anomaly. So again, as Willem has also said, the response is different for each of the El Nino events. This here is just when looking at heat waves. I mean, this is quite a heat waves can have an impact on various sectors. Now, I'm especially thinking in terms of agriculture and health, what comes to mind at the moment. So again, here from 1971, and this is now for the larger summer season, the October to March period, up till the 2015-16 6-month summer season. Again, just highlighting the different El Nino events under investigation here. Well, not really investigation, just highlighting it. Here, the 1982-83 season, for those 9 stations over the country, which is fairly representative of the different climate regions of the country. The yellowish areas indicate anomalously more heat wave days compared to the average. So there quite a number of the stations had more heat wave days compared to what can be expected. This year, where is it now? Sorry, I struggled to see. Okay, yeah, yes, the 97-98 summer season. So even though the temperature anomalies, maximum temperature anomalies, were basically in the average range, not really an anomaly to talk about, we still experienced over some parts of the country more heatwave days than normal. Something to remember. Temperature-wise, maximum temperature-wise, looking at the whole 6 months period, the anomaly not really indicative, not really have a signal, but still over some regions, we did have more heatwave days than normal. Then, of course, the 2015-16 season, basically all of the stations except for East London had quite a number of higher frequency of heatwave days compared to normal, especially the stations over the central interior regions. And these stations actually coincided with our main maize producing regions as well. Okay, so on the next slide, still with the 2015-16 summer season, just to show how exceptional it was in terms of the heat maximum temperature anomalies. Just by the way, here on this little image there, the position of the 9 stations are indicated for those interested, and looking for each of the months from October up till March, October 2015, March 2016, just to highlight that the 2 exceptional months in terms of heat were the month of October and December, where most of the country experienced quite warmer than normal conditions, as can be seen on these 2 graphs here. So what is shown here are the number or are the years from 1971, 70-71 up to 2015-16 for each of the 9 stations represented here on the x-axis. The year with the warmest or the highest maximum temperature anomaly. So all of the green arrows here shows that the 2015-16 year had the highest, was actually the month with the highest maximum temperature anomaly. This year's for December. So one can see that 2015 and 2015 of October and December really broke actually records in terms of the maximum temperature anomaly for that quite a long period, from 1970-71 up to 2015-16. Of course, in this data set here, after 2015-16 is not indicated. And in some places, that anomaly even reached up to 6 degrees Celsius. Quite a distance between the place in the second position. This is just basically the same as the previous info, just represented in another way, in a more kind of a geographical kind of view. Shoot, I don't think you'll be able to see it, but this is now the year of the warmest or the highest maximum average maximum temperature. This is for the month of October, November, December, January, February, March. The red circles indicate El Nino seasons, or basically all the warm colors indicate El Nino seasons. And this year for the month of October, mostly the 2015, October 2015 had the highest maximum or average maximum temperature. But there is, there in the local, 2010 jumps out, and that was actually La Nina season when this highest average maximum temperature for October occurred. Here for the month of November, also mostly during El Nino season. In this case, it was the 5 El Nino season for the month of November. Then for December, again, the 2015, December 2015, part of that 2015-16 El Nino event basically broke records. But even, in this case here, along some of the coastal regions on the far western part of the country, those highest maximum temperatures occurred during a La Nina event. For January, there's a little bit more of a mixed signal, and in many cases there, you can see there are no circles around these years, and that is during neutral ENSO seasons. For February, a few El Nino or temperature records here, or the highest maximum average temperature during February, during El Nino seasons, quite a few of them. But then 2 during La Nina seasons, and then quite a few during neutral ENSO seasons. Then during March, a little bit more, a wider coverage of the highest maximum average temperature during March also occurred during El Nino seasons. And here, for example, the 97-98 season occurs quite a lot over some parts here of the country. So, as Willem has previously said, this is a complex phenomena. Just seeing it over and over again. Okay, so now the talk is going to end off with looking spatially, and now this is going to be with another data set. All the previous slides were based on station data. The last few slides is going to be on a gridded data set, the CPC maximum temperature data set. The station data is incorporated in this data set, but then there are some processes happening to create this gridded data set, which is very nice to work with. So we're going to look specifically now just at heat waves. Important to know what heat wave definition is used, because there are quite a few. In this case, the definition used by the South African Weather Service will be used, and that definition relies on finding the month with the highest maximum temperature for the specific part of the country. And then, here you can see 1, 2, 3 is January, February, March, and then 10, 11, 12 is indicated of with the month with the highest maximum temperature being October, November, or December. Here you can see mostly during January or February, over most of the country. There are little area there where December is the month with the highest maximum temperature. Yeah, anyway, that is just to show you that. Oh, then here also on the bottom graph here is the average maximum temperature for that specific month. So here you can see over the western parts of the country up to 36 degrees Celsius. Yeah, just following the color code. Of course, some of the coastal regions, it is quite lower, about 10 degrees lower compared to the hottest parts over the western parts of the country. Oh, then the definition reads that for at least 3 consecutive days, the temperature must be 5 degrees warmer or higher than what is shown on this map. Okay, so now looking at the long-term mean monthly heat wave days. So just think of it as the annual cycle of heat waves, and we think of it in terms of heat wave days. So just for completeness sake, starting off, I think that is in June. Yeah, so it will be June, July, August, September, and then this is October, November, December, January, February, March, April, May. So, of course, during our winter months, over the central or over the interior regions, heat waves does not occur according to the definition that we use there, but just for interest sake here along the western coast regions, especially when a strong high pressure system manifests itself over the country and with the adiabatic warming of that escarpment with the easterly kind of flow, heat wave conditions can occur over places here, over the extreme western parts of the country, and during the month of May also here, during I think mostly Bergen conditions kind of here along some parts of the south and southeastern coastal area. But we are interested in the month of September, October, November, December, January, the peak month in terms of the occurrence of heat wave days, and then also February. But just in very, I think maybe later on when Johan speaks as well to the impacts on agriculture, I mean, these months are very important in terms of agricultural activities, and especially the stages, for example, of the maize plant and so on. So that is our hotspot times for when, climatologically speaking, heat waves occur. And that has nothing to do with anything of the phase of ENSO or climate change or whatever. Based on historical data, that is when we get heat waves. Your computer wants to update, Neville. Can I just postpone?
Of course, want to update today, right?
I need an update. Okay, so finished with this. Okay, now, oh no, sorry, actually, yeah, that is the right one. Okay, so now, again, going back to that specific El Nino events on the first slide and what Mogile and Johan will also talk about. These are the heat wave days during our summer period, and here this is taken from September up till the following March. Okay, so here for our very strong El Nino event, the 82, 83 event. This is what the heat wave day occurrences looked like over the country. Here we can see the northeastern parts of the country basically had the highest frequency of heat wave days. Let's just then jump to our other very strong El Nino event. This is the 97, 98 event. Quite a lesser frequency of heat wave days occurrences during that specific season. Also, when the rainfall response was not as extreme in terms of anomalously dry conditions as for example, this other very strong El Nino event. This year is the 2015-16 very strong El Nino event, and here we can see in terms of the number of heat wave days as well as the coverage over the country, this is quite noticeable or notable during that specific El Nino season. Okay, so then just to highlight then the strong event of the 91-92 season, then the impact in terms of heat wave days was especially felt again over some of our important maize producing regions and then the Northeast. And then looking at our moderate events, for example, this event here of the 86-87 El Nino season versus, for example, the 94-95 season. Here, another moderate season there as well. One can see that the pattern, the spatial pattern, and also the frequency of the heat wave days is not really, yeah, it varies quite during those El Nino seasons. Then looking at, for example, at the some of the weak El Nino seasons, here the 24-5 season, the 26-7 season, and here this is the 2015-14 season. So again, just highlighting in terms of the temperature response now, specifically for heat wave days, it can actually vary quite a lot. Okay, so, then just lastly, adding the 2018-19 El Nino event, which is classified as, in terms of the sea surface temperature in the Nino 3.4 region, classified as a weak El Nino event. Here again, we actually, just by glancing at all of these images, it looks like basically the second worst occurrence of spatially and the frequency of occurrence of heat wave days. And this was a weak event. So just adding again to the complexity of in terms of when one goes into the forecasting of the specifics of what can be expected even during an El Nino event, as Willem has mentioned earlier. Okay, this is the second last slide. And this is just to show, if we look at the intra-seasonal characteristics of the heat wave days, so meaning when during the summer season the heat waves occur, and now again, just by a case study kind of approach, looking here at the 72-73 season, which was actually quite a strong El Nino event, the 82-83, then the strong 91-92, and the very strong 2015-16. Here we can just see again, confirming the complexity. It's not really easy to say, oh, okay, during El Nino events, the heat waves will occur during the first part of the summer season or the latter part of the summer season. Here we can see this little bit of a mix. 72-73, mostly during the early and middle parts, with 82-83, mostly during the middle and the end part of the summer season, 91-92, mostly here during the latter part of the season, and 2015-16 just all over the place. So, and I think I'm going to stop here, not going to go through the conclusions. I think it's, my time's up, I guess.
Thank you very much. Yeah. So look, again, you've heard that we have a kind of a typical average kind of response, but then we have all of the noise around this complexity, and that I think is really important to communicate. We were going to take our next input on the impact on agriculture, but we had 11 o'clock and I want us to break for tea. So what we're going to do is we're going to get back at 11:30 and we're going to blend those next two sessions. So Mokele's talk will come in with the panel discussion on the 2015 event, and I will use the tea break to look at some of the questions that have come through, and we'll try and get to those then. So we're all going to break now for 30 minutes. Do you know where the tea is? I did see them bringing it in, but I don't know where they put it. So I would say follow the Pied Piper to where tea might be. And we will see you again in half an hour. And Sue Walker, happy birthday. Okay, so I'm going to pause the recording. Pause recording, and I'm going to stop sharing. And I'm going to look at some of the questions. And we will come back in half an hour to continue. Thank you. Everybody will be back shortly. That is 10, 11:30. Thanks.
Oh, speak to me. Okay. Hey. Hey.
So I love kombela ku assistiwa hi kombeleriwa leyi va ri le Lethaba Citrus.
Lethaba Citrus. Can do me a favor, talk to
I see some people have trouble with sound. Let's see what we can do. I hope that you're not muted. Tea break was scheduled, yes, between 11 and 11:30. Let's see what else we got. Okay, let's see what else we got. Good. Anyone is very happy to answer any questions that others have. It doesn't have to only be us that answer questions, so everyone can. Catherine is not well correlated with ENSA. Yes, that's true. Let's see. No. There was a question about whether we can experience La Nina and El Nino at the same time. No, we can't. Certainly some parts of the country can have drought while others have floods. That's possible, but that's nothing to do with El Nino. Sarkoff and IRI, okay. Okay, I think I've covered most of them, but I'll raise these questions again during the event. Okay. Recording's paused. I'll start recording. Okay, let me go and trace everybody and bring them back. Oh, I didn't mean to do that. Am I still sharing screen? Okay, let's see. No, I meant to go to here. Right. Okay. All right, everybody online. I hope you're all nourished. There are a couple of questions here. I'm just waiting for everyone to assemble. All right. Yeah, I need to start recording again. Resume recording. How's it? Fine and you? Amazing. I was just thinking, I wonder how it's going with you, baby. That's fine, it's fine. Excellent together. I gave you some of the time. I got some of the Thank you. All right. Let's call everyone to order. Okay, can we call everyone to order, please? If you look at the program, which I don't know if I'm sharing, let me just share the screen again. Okay, so if you look at the program, we are a bit behind schedule. Mokele is going to give us some input on rainfall impacts of historically, and then we're going to move into a panel discussion to look at some more specific issues around impact before we break for lunch. The schedule is to break for lunch at 12:30. We probably will break for lunch a little bit later than that, so please bear with us. So without further ado, I'm going to ask Mokele to come forward, but now to do that, I have to find his talk, which I definitely put on my screen. It's that one there. Okay, and we're going to.
My presentation needs to be on this.
Preferably, I think I got it. I think I moved it over.
Oh, no, I haven't seen one.
Okay, we'll put it on in a minute. Okay. All right, so this is Mokele Mletsi from ARC, and he will talk to us a little bit about some of the impacts of ENSO on rainfall. All yours. Click there. Oh, you got it. Okay. Cool. All right. Attention, please, everybody.
Good morning. Christine talked about temperature. I've been tasked to talk about rainfall observations, mostly using observational network from the Agricultural Research Council. Most of the services that I'm going to present comes from the data that we have collected from the our observational network. I have to acknowledge contribution from Dr. Malebe, Dr. Rapolaki, and Dr. Roth. My name is Mokhele Moeletsi from the Agricultural Research Council. I think starting first with looking at different El Nino events. As you can see, we have categorized it in terms of very strong, moderate, and weak El Nino. If you look at the 12-month SPI, which is the index that we normally use to look at whether it's dry or wet, you can see that starting first with the legend, red actually means very dry and blue to greenish means very wet. You can see that in very strong El Nino events, the 1983 shows very dry conditions, most of the country. And if you look at 1998, it has been also indicated in the previous talks that it was quite wet. You can see that we didn't have a very strong signal in terms of translating the El Nino into a dry conditions. And the 2015 and 2016 SPI, the data that we collected shows that we obtained also very, very dry conditions in most parts of the country. Moving on to the strong El Nino, in 1988 as well, it was more or less like the 1998 El Nino, whereby we didn't actually get a very, very strong dry conditions. They were actually wetter than normal. While the 1992-93 season, we know definitely that it was very, very dry. And also, if we move on to the weak El Nino, some of the weak El Ninos actually translated to a very, very dry conditions, specifically the 2005 and 2019-2020 El Nino event. In these slides, what we did is we correlated the 3-month Nino index we linked it with SPI. The first one is August, September, October index correlated with the September, October, November index. As you can see here, we are getting a very weak positive correlation. But if you move further towards the mid season to the latter summer season, you can see that we are having a very, very strong correlation between the Nino index as well as the SPI, 3 months SPI. We also correlated the SOI with cumulative rainfall from October to March. The dark parts actually shows a positive correlation, implying that during El Nino years, we tend to have dry seasons, and also during La Nina years, we tend to have wet seasons. But you can see that during the winter season regions, winter rainfall regions, we are not getting a very, very good signal in terms of correlation. Moving further, we looked at the 24 months SPI starting 2021 up until 2023. As you can see, it was mostly La Nina, and we obtained wetter than normal rainfall. This pattern is more or less similar to the pattern that we obtained in our correlation. But if we factor in and move closer and take only January to March, we can see that we are slowly shifting towards a drier conditions, which is an indication of probably the onset of, due to the onset of El Nino. These images shows rainfall anomaly for the strongest El Ninos we had since 1980. The first one, the 1982 to 1983 El Nino event. As you can see, it didn't start with extreme drought, except in Limpopo. We actually got in certain areas, especially in the central parts, we had actually closer to normal and above normal. Red to dark red actually shows below normal. And if you go to DJF, December, January, February, you can see that it was extremely dry up until all the way to February, March, April. But then if you go to 1997, 98, El Nino, you see a different construct here, whereby it started off as if it's going to be very, very dry, but then later on during the season, it was relatively wet. And looking at the 2015, 2016 El Nino, it was the dry conditions were very eminent during the OND period, but also especially in the central throughout the season. But in some parts, you can see pockets of above normal rainfall in those areas, especially on the west and also in northwest. In these slides, we are showing January, February, March cumulative rainfall percentage in terms of long-term mean for the 12 strongest El Ninos since 1980. As you can see different contrasting patterns. In 1982, the JFM was very, very dry period, and also 1987 and 1992. But if you look at 2010 JFM, you can see that that particular period was actually above normal for most parts of the country. More or less the same. Looking at JFM, you can see constructing patterns for different years. Looking at JFM seasonal rainfall. We also had a look at the standardized rainfall anomalies. For specifically these lines, 1972, 82, 97, and 2015, 2016, which actually shows more or less the same patterns that we have seen, whereby all these La Nina years translated to dry conditions, with the exception of 1997, 98 El Nina year. Looking specifically at some of the studies we have done in the Free State, we have seen that during El Nina years, we tend to have an early cessation of rains, but then if you look at onsets, there was a mixed signal in terms of onset, but definitely the duration of rainfall actually becomes shorter during El Nina years, and seasonal rainfall actually is reduced drastically during El Nina years. We further looked at a significant rainfall during El Nina years. As you can see here, compared to La Nina years, there's you tend to have a less number of days with significant rainfall of 10 millimeters and above, and also with 20 millimeters and above. In contrast, if you look at in La Nina years, we tend to have a relatively higher number of days with significant rainfall. Also looking at the totals for one day rainfall and also 5 days consecutive rainfall, more or less the same pattern is we actually see it for both El Nino and La Nina. I think that's pretty much it from my side. Thank you.
Thanks. Well, you can help me, but what I want to do quickly before we go into looking specifically at 2015 is just to try to summarize what we've tried to communicate to all of you today. So the important point is, and I think Willem made this point at the beginning, is that no ENSO event is like any other, because it's not just ENSO on its own. It's a combination of different influences, with this dominant one being ENSO. We've learned specifically that the story is mixed, but with trends. So the trends in the heat are that generally there are more heat wave days when there are El Niños. Some years are worse than other years, but they're not exclusive heat waves to when there are El Ninos, right? Similarly with rainfall, we see that the rainfall patterns and the heat patterns are heterogeneous. It's not only the total amount of rainfall, which generally show drier than normal conditions in El Nino and generally wetter than normal conditions in La Nina, but it's also things like the distribution of rain, where those droughts occur, where those heat waves occur, they are heterogeneous, and things like the onset of rain and the period of rainfall also varies. So it's a noisy, messy story, is what it is. But we can see that in 2015, 16, the impacts can be really severe. So we have to take cognizance of what could happen without knowing precisely what will happen. And the whole idea of this meeting is to start to think about that. And then as this progresses and we start to learn more about how this particular one is manifesting globally, and in particular, how it's manifesting here, we will reiterate this conversation. Have I got it right? Does anyone want to add anything to what I've said? Any of my panelists want to add something at this juncture? No? Okay, good. Thank you. I see we've got more comments. Let me first stop sharing if I can. I don't know how to stop sharing. Help. Hold on a second. Just bear with me while I try and close that. Stop the sharing. Okay, good. So there are lots of comments here. I just want to quickly see. There was one question from Kwesi here. My question is, due to the randomness of ENSO patterns for the seasons and strong ENSO events, would it not be, I don't know what this means. Would it not be at the door of the different ENSO flavors that persist in those different years? So when you're talking about different ENSO flavors, I mean, I think there's a whole variety of different kinds of ENSOs. We're looking at a particular region 3.4, but they obviously vary in strength. And we've seen that the strength of the El Nino doesn't always predict how severe the impacts will be.
Also, occasionally when you have Central Pacific Ocean, this is warming before it warms in the eastern part.
So
canonical pattern development, warming just off the coast of Peru, spreading towards the west. The Central Pacific Ocean, which is Japanese, which refers to as the El Nino Madot. Central Pacific Ocean warming.
So what Willem is saying is that the pattern of warming in the Pacific Ocean also varies and matters. I'm not going to try to repeat exactly what you said, but sometimes it warms in one direction and sometimes it warms in another. There was a question here about marine heat waves. They're really different processes, and I don't think we should confuse the issue. There are indeed marine heat waves. There's a whole lot of work going on that, but this is specifically, we're talking about atmospheric ones. I think that's about the most important questions. What are the projected impacts on rainfall in the Western Cape? We'll get to that just now. I can predict with some confidence that it's raining today in Cape Town. That I can do. And I'm pretty sure about that. Okay, so look.
It's not raining.
It's not raining. I got it wrong.
It did, but it's not anymore.
It was. Okay, so let me just get to this. I've got that. I need to share that screen. So next up, we've got, we wanted to put a little panel together to look specifically at the 2015. Yes, you have a question. Yes. How does this link to the Paris Agreement? Can we hold that question for a bit later? Okay, thanks. I want to move on to this. What we want to do is just get a couple of inputs. Katleho, where are you? There she is. Katleho will take the floor. She'll introduce us. We'll just say a little bit about some of the impacts. Katleho is suffering from a bad throat, but she's going to brave it anyway. Okay, yes. So the floor is yours.
All right. Good morning, colleagues.
and those also online. So we've reached our panel discussion session. I will request that we all engage and discuss and raise our hands, and also bearing in mind that we also have the audience online. So we have seen from the presentations that came in the morning that indeed the 2015 Nino was one of the strongest. Some also predict that might be the one of the strongest in this century. We've noted the impacts and the far-reaching consequences that were suffered, particularly in the SADC. In terms of the agricultural sector, we have noted also some loss in production, deficit in some cereal, as well as having direct impact on the livelihoods. So before we start, I'm going to introduce or request our expert panelists. I can see Dr. Christine. Can I please have Johan on the front? Please, Johan, so that you can be able to engage properly with our audience. Who am I missing? Peter?
Peter's online.
He's online. All right, and of course, Neville Sweet. So what we will do now in this session, we will delve into the specifics so that we can note the significant impact that actually happened, and how it impacted the different sectors, be it your health sector, be it, of course, the economic, as well as the hydrological, which we will just touch base because there is direct link in terms of agriculture and also the water sector. So I will just request now Dr. Johan to come on the floor, and he will be providing his insight, research findings, and also practical knowledge, in terms of the impacts that were experienced during the 2015-2016 El Nino, because what we want to do is to be able to pick up some lessons, from those impacts so that we can be able, to prepare better. Of course, you've noted that every Nino, even La Nina, is different. Therefore, what we know in terms of the impact, we're not sure what will actually come out of these, but then we know that from the lessons that were picked in 2015, we can be able to better prepare the sector itself, and not just that, but also even the civil society itself, because our people on the ground are highly impacted, particularly those that are dependent on agriculture as a way of their livelihood. Also, the fishery sector has been impacted. So we'll be able then, through this discussion, learn from those and see how we can advise our people going forward. You all know about the United Nations Early Warning for All. So through that, we want to make sure that we reach as much as possible, even those people in those rural areas. We need to be able to run that last mile. And the purpose of today will be doing exactly that. So welcome, Dr. Jan. Thank you.
Okay, Johan is about to load his talk. Just give us a moment while Johan prepares his presentation. Thanks, Katlego. Okay. Joel Guy, I note your talk, and I want to speak with you about that afterwards. Okay, it's going to take long. I think maybe we need to swap around. Sorry, Katlego, because he's got a process here. I'm happy to take the space to talk a little bit about health. Okay, so I'm going to just grab the floor myself, just while Johan sorts his thing out. Peter, I see you. Thank you. So I have got a few things to say about El Nino and health, but let me just say a few general comments about climate and health. And what's important to understand is that obviously only some diseases and conditions are related to climate and health. And there's a growing study now of the relationship between climate variability and health impacts. In a sense, all climate impacts health in the sense of health and well-being and food security, and there are all different ways to think about that. But some particular diseases and conditions are very subject, are very influenced by climate, and particularly by seasonality. For example, malaria. As you know, there's a malaria season, right? And each malaria season is different from a previous one, and that's also influenced by control and by migration and various other factors. But we do know that there's a relationship with ENSO and malaria. In an El Nino year, we generally find that malaria levels are low, and that's because generally it's drier, which is not good for mosquitoes. And in a La Nina year, we generally find that when there are malaria outbreaks, they're associated with heavier rainfall and more water, more standing water. So there are relationships. They're not super strong, but they're strong enough to use with some confidence to make predictions. So that's one example. The other obvious one is heat. So if things are hotter than normal, there are all the physiological impacts, and we've got people in the room here who have worked on them. Katlejo, who's worked on them for her PhD, and where is she? Can't see her now. Other people here around the place who have also worked on the impacts of heat. And of course, if we see extreme heat and heat waves happening, Sarah, where's Sarah? Oh, there she is. Couldn't see. So Sarah's worked on that as well. Extreme heat will also have an impact on that. So clearly there's a health consideration, a health sector consideration. And just to make my point, I want to show two slides to you. And this is about diarrheal disease, which is something that I've worked on. I need to share the screen here. Share the screen. There it is. Okay. So I'm hoping you can see this. So I'm going to try to explain what you're looking at. It's an interesting story. We haven't come to final conclusions yet. But this is an anomaly of an index of the incidence of diarrheal disease that occurs across the country for about 8 to 10 years. So it's 112 months worth of data, which actually ends in about 2021 or 2019. Okay, so it's 10 years before that. And basically when the blue graphs, the blue lines are above zero, it means that there's more than average, the long-term average, and when it's below, there's less than average. And it's complicated by this very big thing in the middle here. This was a period of a year or two, 2012, 2013, where the incidence of diarrheal disease in the country was high. And we can't explain that. It's nothing to do with climate. Okay. So this messes up our data, which makes it complicated to explain. But there are other periods when it was also high. There was this period here, and this is interesting because it was a winter months in the year 2010. You can probably guess what it was that caused the diarrhea outbreak in the country in 2010 in winter. That was the Soccer World Cup, right? So we had a lot of people bringing in bugs and different flora into the country. And then there's another one, and there's this one here, this event. And this event happened in 2015-16 over the summer months. And that was the bad El Nino, the 2015-16 El Nino. And so the hypothesis, we can't show this yet, but we think that hotter and drier conditions lend themselves to diarrheal disease, to the promotion of diarrheal disease. So that's one of the things. And this was interesting because it was ubiquitous. I'm just going to point out one thing just by the by, and that's this last one here. And interestingly, there we had a spike of diarrhea, but only in the Western Cape and the Eastern Cape in about February 2018. And that, you might recall, was the end of the day zero drought, when level 6B restrictions came in the Western Cape. People stopped using water. But that's the thesis. So what this is showing is that there's a signal in the diarrheal disease incidence. Then the other one I want to show you is something else quite amazing. Again, I just want to make sure that I am sharing this. So let me just do that. So this then, it's actually the same data And what this is doing is it's correlating the sea surface temperature with the sale of Imodium in Polokwane. Say that again. It's correlating the world's, this is what scientists do, okay? It's correlating the world's sea surface temperatures with the sales of the pyramid in Polokwane. Okay, and what you see is very interesting because this is 3 months lag, so there's 3 months between the two data sets, 2 months lag, 1 month lag, and naught. And what you see is you see this red patch over here developing there, getting a little bit stronger at 2 months, even more strong at 3 months, and at 0 months, so the month of the sea surface temperatures and the sales of the Imodium, we see a strong correlation. And that there is exactly what El Nino looks like, the sea surface temperature anomaly. So there's a relationship between ENSO and disease. And that's really all I wanted to say, is that we are cognizant of the fact that there are these relationships. And so the health sector has to respond to that. I'll stop there. Johanna, you said, okay. Right, so let me stop sharing there. Let me pop this one on. Sorry about that, Johan.
Well, whenever we're setting up, we know that there are more direct and indirect health impacts that occur because of La Nina. Neville touched on the diarrhea, but then we know that there are those direct impacts that has to do with kids exposure to kids. We noted that in 2015 there were some people that died in the northwest. I know it's about 11 or so. However, we might have more deaths in South Africa. The reason maybe we are not recording, as much as the other countries in the world is because of how this data is saved in our health system. But that does not mean that we're not experiencing those significant numbers that we're noting everywhere in the world. So we need to start somewhere in terms of properly affording, the health impact in our hospital systems, as well as also in our clinics. That way we then be able to have those proper correlations, and that we can be able to to associate these things. We are far from that in terms of those records, but then we can use most of our meteorological data that we have from the different sources to be able to have an idea of those direct impacts. Johan?
Thank you.
We'll be looking into the agricultural sector, and what we want to know from my side, what were those long-term and short-term consequences that were felt during that 2015-2016 La Nina? Thank you.
Good, thank you. Just quickly, I don't need the mic, is that correct? Okay, fantastic. Good. So, as you know, this is the theme of my talk quickly. Let me just see how you forward between the slides. It's not with the arrow.
It should move an arrow like that, but if it doesn't, then do that.
Okay, great. Good. So this map is a bit familiar now. It's shown earlier. It shows the correlation, the significance of the correlation between El Nino and drought in South Africa. And in that specific region there, that is our important grain production region. And you can see especially the western half of that little area with the, you can see it faintly with the little blocks there. That western area, we usually see quite strong impacts by El Nino. Now, the reason for the impact of El Nino on our grain production in South Africa, it's clear, it's warmer and it's drier. And in some areas in the country, we also have different types of soil. So there's a bit of heterogeneity when it comes to the impact of El Nino on our crops. Now, this is for two specific areas in the country. The one is in our eastern production region and the one is in our western production region. And for these two areas, you see there are two very important parts of the growing season when maize is really more sensitive to a dry period of multiple days, exceeding 20 to 30 days, exceeding 20 days at least. Those two parts are over the eastern parts, which is the blue line representing the eastern parts of the production region. That's when it's plant time, and that is late October, beginning of November, and it's again around late January, very late January, and mostly early February to mid-February. Those are the two very sensitive periods for maize production in South Africa. And that latter period in February is very important for both the eastern and western parts of our production area. So the correlation between rainfall and yield is much higher, and that's why these two lines go up. Over the western production areas, there's another peak a bit later than in the eastern part, and that is because they plant later. And that area is around early December and also late November, where they have a stronger correlation with the rainfall. Now, the thing with El Nino, if you just look at the second period that is quite sensitive, which is early February, this is for the eastern parts and this is for the western parts of the production regions. And the most important thing that you see here is that during La Niñas and El Niños, there's not a big difference in the rainfall that ends by late January for a 30-day period. So El Nino don't necessarily influence that part of the season where there is a lower correlation with yield, which is the early part of January. That's a typical midsummer drought period. But if you extend that drier period, or if it shifts a bit later, then it is much more sensitive. And you can see with these two graphs that, and this is for the east and for the west, actually, that the rainfall distribution is much different during the 30-day period in the end of February than during La Niña than during El Niño. So these two blocks are much less overlapping, showing that during El Niño periods, that sensitive part of the growing season, it's much more susceptible to drought. And that is why we see these big impacts on our yields. So in 2015-16, the big issue during that, and that's our previous El Nino, was that we had extremely dry conditions over the country, most of the country, especially these western production areas for maize, and also the lowveld, as you can see there, and much of KwaZulu-Natal. So it was extremely dry from October to December, and it was very warm. This line is for an area near Potch. That upper line shows you the maximum temperatures, and this is for the month December to January and February. And you just can see how many days there were temperatures exceeding 35 degrees Celsius during that time over our production areas. And a temperature above 35 degrees Celsius is in itself not good for maize production. You cannot even have wet conditions, but those temperatures are directly negative. So one of the aspects that we did discuss about the El Nino in 2015-16 was the very warm days. And this is just showing that we had quite a dry and warm period up to early January.
Okay, fine.
These are some of the maximum temperatures recorded during that early part of January. You can see most areas exceeding 40 degrees Celsius. And these are the vegetation impacts during that summer. This is from July 2015 to 10 March 2016. And these are the production areas for maize. Those are our wildlife areas in the Kruger National Park, southern parts there. And these are livestock areas in KwaZulu-Natal. And there were quite big impacts in those areas during 2015-16. Just quickly looking at these lines, if you look at the livestock in South Africa, the green line is the price, and the blue and red line is a number of animals slaughtered. And you can see that during most of this time, from 1970, there's quite a good correlation. But when you look at the period 2015 to 16, those two lines cross. That means people couldn't keep all the stock during these dry conditions, a big negative impact on vegetation activity and grazing. And for that reason, people had to get rid of their animals, and livestock prices went down even as more animals were being slaughtered. Over the Kruger National Park, luckily the impacts were a bit more in the south, more localized than during a previous El Nino, like in 1992, also in 1983. That means that the animals could move around over the park, and for that reason, there were somewhat lesser impacts during this specific 2015-16 El Nino. So that tells you again the importance of the distribution of rainfall over and above the temporal distribution of rainfall that is also important during El Niños. Now, our longer term setup at this stage, we look a bit better than in 2015.
So by the middle of 2015, because before we had the real El Nino year, this was a 2-year SPI, Standardized Precipitation Index. In red, it shows you areas of severe to extreme drought at the 2-year timescale. That means these would have had quite significant impacts on the levels of reservoirs over these areas. At this stage, we are coming from a 3-year La Nina period. So at the 2-year timescale at this stage, we have extremely wet conditions over South Africa. So at this stage, the water levels in the soil and in the dams are looking somewhat better than in 2015. It's not to just say that things will change a lot during the coming summer, but beforehand, especially for the early part of the summer, for irrigation, it looks a bit better now than it did during the 2015-16 summer. So these two lines go together because El Nino, when it's stronger, usually we have less production of maize over the country, and you understand why, because of those temperature and rainfall impacts. This is an important example for is 1982-83. The year thereafter was actually La Nina. It was also a low production year. This is a 1988 El Nino. You can see big discrepancy there because we did have good rainfall over the right parts of the year over South Africa. And this is a year that we are focusing on now, our previous El Nino, and you can see those lines went together down again because it was a strong El Nino and because of those temperature and rainfall effects that we saw, and also a dry previous season, we had a very strong negative effect. Now these bars give you the total production estimates for the years 2010 to 2020, and you can see those are the 2 years in a row that were dry. The one we focus on is the second one. Production during these years were about 40% lower than during the previous summer, 2014 summer, and that just shows you how negatively we were impacted. And we had to import maize because of this lower production. So by early January 2016, this was a new news from Grain SA regarding agricultural production. I'm just going to show a few snippets here. They mentioned that less than 50% of the maize were planted by January, which is very late in the planting season or in the South African summer for grain production. Over the northwest, but only 30% of maize hectares were planted. Over the Free State, 23%, and 66% of the Eastern Free State. So you can see that impact because of the distribution of rainfall and temperatures in 2015-16 really had a very negative effect during the planting season for production year, and it had a very negative impact in the end. But the impacts of El Nino, as you know, is a global thing. In Southern Africa, we also see quite large negative impacts over the countries to the north. So in our region, that creates some trade impacts because some of these countries import maize from us during dry conditions. And typically with a large El Nino or many El Nino situations, you get a Southern African footprint. So for that reason, we see impacts over the entire region, and it also has a trade impact. When we look at the effects of El Nino, and Willem mentioned this earlier, we see that over two of the biggest production areas for grain over the globe, there is not a strong negative effect, but rather positive. During La Nina, those effects are more negative. That has an influence on the availability of grains worldwide, and that has an impact on the price if we want to import or export from South Africa. So because during La Nina, we have in this area, which is Brazil and southern Brazil specifically, we have a rather positive effect in terms of rainfall. And in most of the USA, we also have a positive effect in terms of rainfall during El Nino. We see that usually grain prices globally is somewhat subdued during El Nino conditions, which is good for us because especially if we have to import maize, those prices are somewhat lower. Now we know that the prices went up during the last year or two. The reason for that was drought that occurred specifically over Brazil. This is by September 2021. That has an effect on the production globally, sending up the parities of the international price, and that's why our maize also become expensive. But in a year like 2015-16, because we have to import, that has a very, very big impact on us because we usually trade below the international price if we keep everything for ourselves. And that was the situation during September 2015. And you can see over Brazil and the USA, conditions were quite good. And there were a good production during that year. And we didn't have such a high international price. but still our prices went up quite a lot because we went above that. Because internally we couldn't use enough and we had to import, and that's where these two light blue bars come from on this graph for the 2016 and 2017 summer. We usually have a knock-on effect towards the next summer, because if you produce not enough in one summer, you already don't have a carryover to the next summer in terms of the production of grains in South Africa. So usually you will have a 2-year effect when we don't produce enough, and that has quite a big effect on the rand price of our white maize and yellow maize. And there you can see the spike that happened during 2016 and 2017 based on the low production that we saw during 2015 and 2016 in South Africa. And again, the last few years, you see we had a lot of production, many millions of tons. We can export. We don't have enough infrastructure to export everything we can. So our prices at this stage, even though it's high, and one reason for that is rand not being very strong, we still are much lower than the international prices at this stage. So just to summarize, we know that the impacts vary. 1998, as we know, was much different than 2015-16. We had a cumulative effect in 2015-16 coming from a drier previous summer. At this stage, it looks a bit better than then because we're coming from a 3-year La Nina. So the water resources, the impact initially is not as strong. Multi-year variability is very important when you look at the impacts of El Nino, in other words. Also, intra-seasonal variability is very important. As we saw during 1998, the rainfall, and I didn't mention it earlier, but the rainfall really only started by late December, but that was just in time for the production to be quite positively affected during the 1998 production year for maize in South Africa. We also see that El Nino affects the import and export ratio because it affects our production, and it also affects worldwide production, and also that affects our price. Thank you.
Thank you so much, Alan. I think maybe we take some questions for the health sector as well as the agricultural sector before we proceed to talk about the weather itself that affected, and as well as the economic aspect which Johan has touched base on, but it will get into details. Yes, Prof.
And Johan, who benefits from somebody making a forecast?
Oh yes, this is the future trade.
Can you come here and repeat the question and answer to this computer? Thanks.
So who benefits from somebody actually making a skillful forecast related to trade?
I think insurance companies can benefit quite a lot, and then also futures traders globally. Big future trading market on that. And while intra-seasonal variability is very important, the moment there is an El Nino forecast and the global community realizes that the impacts are starting to occur, there are quite big moves in the market in cause of that. Usually the market will wait to see evidence at this stage, but if you know that your forecast is absolutely correct, without a doubt, then it will give you a benefit to trade in the correct direction. Even though smaller hiccups can happen in the trade in between, the longer term trend will be in a specific direction, also very much influenced by global weather patterns.
Because if we can actually look at that map where the impact is, it's exactly the area where Nino has the strongest influence and where forecasts work the best. Yeah, so it's got to be a way to pull resources and start to predict trade related.
It does, and at this stage, becoming no actual effects in South America currently, with above normal rainfall with the southern parts of Brazil, is having a negative effect on grain prices. But at this stage also, in the USA, there's a drought over the main corn production region. That now has an elevating effect on their prices.
Stand there and ask questions.
All right. Thanks. I want to ask a bit more about the last kind of 2 years of your time series. So was it a high production phase or a high price? And do you know why? Is that because of the wet years?
Yes, so
Can you just repeat the question and the answer?
so you're asking why the bars were high? Is it high production for the last 2 summers? And that was for maize. Now in the previous summer, because when you have more than one wet summer in a row, you start getting cumulative effects. The 2021-22 summer over our western production areas, they have a lot of soils that has a shallow water table. So if you have too much water, the crop starts to drown, it gets waterlogged, the entire area, and your production is lower. So waterlogging happened in December 2021. And that's sent up South African prices because there was a scare about sufficient production. And that was within the context of higher global prices as well. And that was related to the negative impacts of La Nina on Brazilian and USA rainfall.
Have you looked at the relationship between an air pollution like ozone and agricultural?
There will be a connection, statistically speaking. As you know, every year the rainfall pattern differs, even with the same kind of strength of El Nino. So that will tell you that the wind blows from a different direction. Sometimes more strongly, there's more rain or less rain in certain areas. But there will be a correlation, and it will usually be, if it is drier, it gets more dusty. And there will also be more ozone and more of these pollutants in the air. Whereas if you have a more active weather pattern, more low pressure systems coming through that we expect in La Nina in South Africa, then usually you will have less pollutants. So there will be that correlation. I'm not sure if there are any studies. I can't answer that, but I guess there would have been.
I'm gonna take just, okay, 2 questions and we'll make another round. I'll start with you, sir, and then so.
Your question based on the 1988 period. I think there's a graph that you had on and it showed that the intensity period that is principally to the 1988. Yet, they had the almost the same impact on the units production. However, I want to know how statistics can be of yours.
Thank you for the question. Did you refer to the 1998 El Nino and the 2016 El Nino? Yes. In the 1998 El Nino, because the rainfalls just started 2 weeks earlier than the 2016 El Nino in South Africa, we had a good production. We didn't see a significant reduction in maize for South Africa. But in 2016, that was a very significant reduction because usually the changes are 5 to 10% between the years, but that was 40% less than what was produced in 2014. So there was a big difference. The total amount of rain during 1998 was also higher basically than in 2015-16. And then the drier period during 2015-16 extended longer. So it had a very significant effect on maize production, whereas the 1998 didn't have a negative effect that much on production.
Just one last question. I see you use the maize as your I also crop. You also look at other crops. Agro-food, particularly there's a
Another crop that is very much influenced like this, because we also planted over many of those areas, is soybeans. South Africa is has quite a big soybean production as well, and that has kind of the same impacts. In the case of soybeans, wetter conditions towards the end of the season has even a larger negative effect as well. So in the case of soybeans, you don't want a wet March, April, May. Where in maize, you can kind of tolerate that. So there's a bit of differences in the type of impacts, but that is the other crop that we know of that will be, and anything that is irrigated and is a grain. There's a saying, rain makes grain, because usually over most parts of the world, you need more rain for better production. Even over the years, as you have new cultivars that is much more resistant to dry periods in specific parts of the season, it is still very much correlated. And that's why at this stage, for example, if you look at the USA, their prices is going up because there's a drought in their Midwest or their corn belt at this stage.
All right, no, thank you so much. Just last one question and then we'll move on. All right.
Look at the correlation between invasive species. Because invasive species can also increase temperature and the El Nino effects with the effect on rural agriculture.
Not that long line, but so I mean, I guess that is that will be a very interesting study. During the 2015-16 event in the Kruger National Park, what we call circle balls.
Yeah.
No, what's the name?
Is Stupulgaris, which are referring to most of these.
Right, so those actually died off over parts of the Kruger National Park during the 2015-16 drought. And the long-term effect was actually positive for grazing because of what happened there. So that is one example I'm very much aware of. So some of those invasive species can actually die off during a very extreme drought event.
But if you look at the adverse effect of that, people with the sophus and arid invaders will increasing the temperature by 2 degrees per year with the increase on the invasion. If that get on media and it could have a drastic impact on the crop.
It will probably, and also grazing. And as you know, during El Nino events, there's more pressure on grazing, and that also opens up large areas for the invasive species to move in.
All right, thank you, thank you, thank you, thank you. A round of applause.
Just a technical note, we have to get, we've got 2 more inputs here,
Yes.
but I just want to check with Peter. Peter, can you just unmute for a minute and say hello? I just want to test if the speaker's working.
Hello.
Not.
Hello.
Okay.
Testing 1, 2, 3. Testing. Testing 1, 2, 3. Testing.
1 second.
Testing. El Nino, La Nina. We're all going to die. Testing. Testing. Testing.
Okay. Well, they heard you, so that seems to.
Okay.
Okay. All right. Somehow or other the speaker's not working like it should, but we'll make a plan. Sorry.
All right.
Go ahead.
All right. So Peter, we will end with you. Now I just want us to look into the impact or the implications of weather. You will remember in 2015, we had a lot of high record maximum temperatures around the country. We even reached close to 50 at some point in the Western Cape, isn't it? So not only the maximum temperature in terms of the changes in the seasonality and also those extreme, but also we've also noted that we had some wildfires. So Dr. Christine and Chabel, we're going to talk about the impact of weather itself by the El Nino. Welcome.
Thanks, Katlego. I don't have any slides for this now.
No problem.
So,
Go ahead. I'm just here.
so in terms of heat, I think I'm basically going to speak about heat, but heat is, it's actually not something that one can isolate. I mean, heat have an impact on agriculture, as Johanna have shown. And heat also has an impact on health, as Neville has shown. So now that we know exactly the effect of also the areas where maize production were affected in the 2015-16 season, either the western and the eastern part of the maize production region, as shown by Johan. Those are also the areas, especially the western part of the maize production area during the months of October and December, and where the heat wave days had the highest frequency. So, and temperatures there, as Johannes mentioned, that for the maize plant, temperatures above 35 degrees Celsius is not good for the growing processes. That is typically what happened there. So that was quite an impact. Also during that time, especially during the month of December and into January, over some of the Eastern Cape areas, and another kind of impact of the heat was felt. And that was on the elderly people. I know of, I think 2 old age homes where people died because of the heat. I have a figure of 6 people that died at that time, at that point in time. Old people that the heat was just too much for them to handle. So, so what I want to come to is something that we maybe sometimes forget.
Sorry.
We think like of health in the more general sense, and of agriculture more in the general sense, but the people working in, for example, the agricultural industry, we've got many laborers that physically works in the field, outside. Their working day starts at early in the morning up to 4, 5, maybe sometimes longer in the afternoon or early evening. People are exposed to heat. And so I think the point that I would like to make is that we don't sometimes realize when we dehydrate. So yeah, so I think I just want to end off with that, is that in terms of alertness, as Neville has mentioned, part of the focus of today is to carry out the message to be alert of especially people with, and this now includes anyone, even people doing sports outside. I mean, I can be a whole Saturday in the sun there, a huge headache by evening, but luckily we here in the cities can get help quickly. People in the rural areas are not necessarily that aware of what is happening to them. So yeah, maybe just a little bit of a focus on the impact of heat on people being outside, be aware of dehydration. So Neville, I hope this is what you had in mind.
That's wonderful. Thank you very much. Thank you. Thank you. Peter, I know that the speaker's working, but because it's going, there's some systemic problem that Zoom is not pushing through the speakers, and I don't know how to find that. Fix that.
Testing 1, 2, 3, testing. You can't hear me.
We can hear you, but it's coming out of my computer and not out of the speaker. So I don't know why that is, but if we're all quiet, then the 40 people in the room will be able to hear, and the 280 people online will clearly hear you, Peter. So,
Right. Well, you want me to go ahead? I won't be long. So now I'm standing between.
Please, Peter, and you can share your screen if you want to.
No, it's fine. I don't have a presentation.
Okay.
So now I'm standing between everyone and their sausage rolls for lunch. So I'm really not going to be long. I just wanted to thank both Johan Neville and Christine for raising some issues that really I'm not going to repeat. But essentially, if you look at the economical impact of El Nino, it all starts with the production of crops. And since maize is one of our main products, am I still there? Yes, I'm still there. Seeing as maize is one of our main products, that's got a knock-on effect through the whole value chain. We must first understand that when it comes to maize, we've got 2 types of agriculture. We've got commercial maize agriculture, and we've got small scale. Some people call it subsistence, but this is what people require to be able to eat. And that's where food security comes in. Food security is related both to what people can grow and what people can buy. Now, when it comes to maize production on the commercial scale, we must understand that it's a commodity. It's available worldwide. We don't have to make enough. We don't for wheat, for example, and we all still manage to get bread every day. So there is a fluidity in that we can import maize if there's surpluses, and as you've seen very often during an El Nino, there are surpluses around. But that doesn't really help a maize farmer. A maize farmer wants to grow maize at a profit and wants to sell at a high price. So when it comes to an El Nino situation, what we've got is lower rainfall and lower yields. Many cases, farmers will cut their input costs because they know that they're not going to get high yields. They won't farm in marginal lands. They won't use as much fertilizer. And they're hoping that the little crop that they get, and yields can go right down to 1 ton per hectare, 1.5 tons per hectare, from usually 5 or 6 tons per hectare if it's rain-fed. And they're hoping that a little crop that they do will sell at a higher price. Now, those higher prices are factored into the market usually according to supply and demand, and we're already seeing prices starting to rise for futures where they peak at the end of next year. So farmers will sell their maize at certain times and they'll contract to try and get the highest price. Now, of course, with lower yields and higher prices, two things happen. One is that people who can irrigate, they don't suffer from low yields. So they're irrigation farmers, and they are irrigating their maize. They are going to score if they've got water because they're going to benefit from the higher prices, and they're also not going to suffer because of lack of water. They may be impacted by very, very hot days, but they can usually do something about it. The second most important thing is if people have to buy maize, and this is a lot of people in our country, because maize isn't just sold as maize, it's sold in many, many products and right across the value chain. People are going to have to pay more for maize. So two things happen. People who are growing their own maize could suffer shortages, and people who buy maize who are not growing their own maize are going to pay more. And this could have severe impacts on the sort of food security and poverty levels. And poverty levels affect all of us. And we know that after a drought, it costs billions of rands to recover back to normal levels. The second thing I want to look at, and that's maize that I've spoken about. The second thing I want to look at is meat prices, because most of our maize, well, let me just put it this way, 60% of our maize goes to feeding cattle. 40% goes into maize meal and other maize, edible maize products. That's the white maize, and the yellow maize goes to feeding cattle. Now, if there's a shortage of maize to feed commercial cattle, then that price of commercial cattle will go up. The cattle producers will import maize. The cattle aren't going to die. Those cattle will be well looked after because it's all factored into the price of meat. However, again, it affects people who've got cattle, growing cattle on their own farms. And this is the tragedy, because those cattle will get thinner and thinner. If the meat price goes up, that's all very well, but they've got fewer kilograms on each cow or each bull, so they will get less money. That is an impact on them. The third thing I wanted to look at is water costs. Obviously, if we are suffering from a drought, there are water shortages, municipalities, irrigation boards, and we're not really talking about the coming season because I think our dams are pretty much full, but we're talking about later on in 2020, early 2024, and if the El Nino persists, then into 2025. Water costs are going to increase, and this will obviously impact on yields and prices of commodities. It will also impact on the opportunities for providing safe drinking water to residents, and this includes the whole water and sanitation issues. So, as Neville has said, there's a very good chance that we are going to see increasing cases of diarrhea. Now, that's something that we can't really put a cost on, but it does have an impact on the health services. Very lastly, I just wanted to say that there are lots of issues when it comes to self-employment and the way people make money, specifically in the agriculture and food value chain. People you don't see and you don't notice, but there are going to be economic impacts. People are going to lose jobs. People are going to have their activities curtailed. So that is something that's very, very hidden. And even though I said that was lastly, I've got one other point to add in terms of health, and Christine did touch on it, is that air conditioning is not widespread in South Africa, and very hot days are going to have an impact on the efficiency and the health of workers, both out in the field and in fact in offices. We know what happens when people get hot under the collar, and someone mentioned in the comments about violence. There have been indications that increasing heat does have an impact, a positive or a correlation with violence in our homes. So the very last thing I wanted to say is that disaster declarations, if they come, when they come during droughts, are expensive for the government. The government has to fork out extra money in providing food for people who are suffering. And essentially, there are very few winners when it comes to a drought situation. Now, I've spoken specifically about drought and not El Nino. I've referred to 2015, 2016. And it does look like the market is responding in a similar way for the coming drought. Thanks very much.
Any questions for Peter from the audience here before we have questions online?
I see there was a question about load shedding. I'll just respond to that. Obviously, irrigation is going to cost more and is going to become less convenient with load shedding. So that has a compounding effect.
All right. No questions from the audience here. So a round of applause to our expert. Okay. So I'm going to take just 5 round questions, and then we'll just have short discussions on the different sectors. Any questions? You had a question? So please go ahead.
I just want to check if we do have outcome data for disease surveillance. Because I think the diseases like malaria, 2015-16, the outbreak that happened, it was around April and May. So I'm wondering if we do have such data. And again, how is the frequency of data sharing for epidemic preparedness and response, diarrhea and also malaria?
I'll repeat the question, and I'm assuming it's directed at me. So the question is really about the surveillance data, what kind of quality of surveillance data we have for a variety of diseases, right? Malaria and others. Look, the NICD, their major mandate is surveillance. And as I understand it, one of the distinctions is that some diseases are notifiable and others are not. So malaria is notifiable, and they've got good data on malaria, really good data on malaria, but others are not. So diarrheal disease in general are not notifiable. The data, there is monitoring, there is surveillance, but it's mostly at sentinel sites, and it's really for the biology rather than, in other words, which agents of infection rather than incidence. But you can get the data, but it's not routinely surveyed. So outbreaks are usually detected late. Cholera is another story altogether. There was a question here about the relationship between the climate and the breakdown of some of the, the cholera-related issues, the waste management. And I don't think there's any relationship there. They're unrelated issues. So to answer your question, it's a mixed picture. I can tell you that, for example, in some of the rural hospitals, Karidi Wright and her colleagues and Tandi Kapwaita, for example, they did some work on diarrhea in relation to climate in Limpopo. And in some of the institutions there, everything's still handwritten. And so to get that data, you have to transcribe that data, so there are all sorts of issues there. I hope that kind of halfway answers your question. You don't look satisfied.
No, it's fine.
We'll pick it up later. Okay, thanks.
Yes, thank you.
So, Sonia, is it possible to hear when people either ask questions or make comments, to just give a brief about themselves so that it makes interaction?
Okay. It would be nice. Let's just keep it very succinct because we've got very little time.
Yeah.
Okay, thanks.
Thanks, Kate.
Well, mine is on the segment when we talk about data on how it's being like from and all of it. But then what is being done in terms of the infrastructure, especially looking at public health facilities, which is where most people are likely to go when they either have malaria or diarrhea or whatever experience.
Again, I assume that's directed at me.
Yeah, you can go ahead, but what I can maybe try and answer your question is that in terms of our infrastructure, we're a little bit behind. But there are those basic things that we can do within our communities in order to try and mitigate some of the impacts, just basic education, advising people to stay in the shade and all that. In our public health system, now we're struggling with load shedding, things like AC. It's actually a luxury. When you go into those places, it's hot, but then we need to start somewhere and try and introduce some natural, mitigating factors that we can bring in, planting of more trees and making sure that people drink water and all that. And I know it talks directly also to access to water and all that. We're having an issue now in Hammanskraal where people don't have access. So some of those basic things we need to have in place, and we talk directly to service delivery, which is another level. But at some point, we need to get to talk about those things hand in hand. Because some of those mitigating or interventions that we're introducing, they need, to have those basic services available for our people. Neville?
No, I think you've answered perfectly adequately. I just want to add that I think that, what we're talking about here is the climate variability and climate impacts and extreme impacts on health. And we can go on forever about that. And clearly there's an independent problem of health quality provision in South Africa, right? All we can say is that we anticipate that as intensity of extreme events goes up, so that burden on the health sector is going to go up. And so infrastructure needs to not only account for its current deficiencies, but future deficiencies. That's really all we can say.
Okay, quick one.
So the president of climate one of the things that came up was that there was no institution of health formation, and it was meant to obviously foster a just transition for also ensuring that people are not affected by all of these changes, particularly in community and financial. So as people who are within the climate change space, have you tried to sort of advocate for the inclusion of health in that commission, or are you still going to be there?
One of the advocates. Neville is one of the advocates, by the way. But we need more people who will really be the voice for us all. Neville?
I'm reluctant to continue this debate right now. I mean, I think because it's about health systems, and that's not really what we're here to talk about. So I'm happy to give you my opinion over lunch, but I'd rather if we could take one or two questions from here.
All right.
So there was one. So Peter, thank you very much for answering some of the questions for us online, because we haven't been able to take too much cognizance of them. I think there was a question for Johan about agriculture. Let me just quickly find it. Yeah, there was one
about the dams that aren't all full, Neville. I think that was the one.
Which one was that one?
Now, there was a question about, there were a comment that not all the dams are full, so the expected La Nina didn't fill all the dams, and that's going to have an impact in coming drought.
Right. The question for Johan was, what is the confidence level or variance when correlating maize yield to ENSO? That's really the question. Okay, his answer is it's strongly positive, but he doesn't have exact number with him. Yeah. With El Nino strongly negative, right. Okay, there's a couple of pieces about microbes. I mean, questions about microbes, and then mostly complaints about audio in the room. Let's just see. Yeah, and Peter's doing some answering. Thank you, Peter. And there's some other comments here. Christine mentioned early mortality amongst aged during heat waves. Another aspect to be cognizant of is that it's well documented risk to infants and young children from severe dehydration. Indeed, that is one of the consequences of diarrheal disease, the mortality. In fact, people might poo-poo the idea of, if you'll excuse the pun, of diarrheal disease. It's the second biggest killer of children in the country, actually. It's really important. I don't see any more here, and I think we are almost good to go.
Only 3 hands will take at the moment. I'll start with Sade.
Hi, Mark from Arma. You've been talking about health effects. In terms of disaster is there a correlation in extreme weather events such as cyclone patterns in Madagascar and the mainland that correlates with the things that we've been hearing so far? So I've heard there's a variance, you can't predict that. extreme events don't necessarily correlate. But are the incidents of cyclone events that are occurring that then bring likes of disaster impact of high levels?
By more tropical storms, you did mention it.
During La Nina, tropical storms within the Indian Ocean, the southeast.
I'll repeat for the people on the line.
Not necessarily increasing the number of tropical cyclones, but increasing those in the Atlantic. And in the Atlantic, there is no event.
So the question was really, is there a relationship between tropical storms, especially on our east coast, and some of these signals we're talking about? And the answer was that it's not so much the frequency of these storms, but their tracks really, and that they tend to make more landfall and therefore bring more storms. But during La Nina events, yes.
They occur in the same year.
The question about lag effect, don't know.
Because they have the main season that coincides with.
So it's yeah, so it's seasonal. Yeah. There was also a question about the impact of ENSA on the Western Cape, and in general, as we've heard other people say, there's very little correlation or very little data to support an influence. But there are some papers. Mathieu wrote some papers that there are signals that are apparent. Now, I can say that our diarrhea data, the Western Cape was as affected as the rest of the country, but it's hard to say whether that's because it was hotter and drier, which it normally is hot and dry in the Western Cape during summer, or whether it was just people moving to the Cape who were sick. So you can't tell really. So yeah, that's about all I've got here.
Then we come to you and then we'll end with you.
Well, mine is more to comment than question. I saw in the final discussion that we had water supply included there, so I thought we maybe touch on that and see what to expect from a water supply point of view. Because I mean, basically from the days ago story, and even on our own area of operation, the previous drought, that we also follow restrictions. So just looking ahead, as any of our experts looked at how the water sector. I know we need this outcome is winter and summer might not be too problematic, but going forward, are we expected to work?
Just to repeat the question. So this was a colleague from Umgeni Water who's concerned about the impacts on the water sector in particular. I assume water supply and reticulation, and in particular the longer term impacts. Perhaps not this summer because we've got a good store of water ostensibly, but going forward. And yeah, that's the question.
Well, the data for food, it's another El Nino 24-25 season. I think we're gonna have much bigger impacts than what you might expect now.
So Willem was saying that, you know, it depends if this persists into the following season and we start seeing depletion of whatever supply we've got, then obviously it will have that impact. But it does also pertain to the future of ENSA, which we will talk about this afternoon.
Another reason why the 2015-16 event was impactful was because of the weak El Nino they had preceding that season.
Right.
So Johannes mentioned the fact that lots of rain, the soil is saturated down to full, so the impact cannot be as severe.
Right. So let me just repeat that. So the point is that the 2015-16 one was so impactful because it was preceded by a drier season prior to that. So there was a cumulative effect. So again, assuming that we get the same drought signal as in rainfall signal, as in a severe shortage of rainfall, we do have reserves. The situation and the impact may be different because we've had 3 years of kind of La Nina conditions. Similarly with the Western Cape, you know, if we have failed rain next year, that's a winter rainfall area, we've got lots of water to last us for at least another year. But the long-term effects are important, and that we will deal with this afternoon.
Just one last question and we'll wrap up our session.
Yeah, thank you. I know just a couple of people on the padlet asked about wildfire and I wondered if anyone.
Are you looking at the padlet?
Yeah,
Did you say?
yeah.
Oh, good for you, because I'm not.
Yeah, I'm quite interested in that as well. So I was just wondering if any of the panelists could say something about wildfires during 2015.
Not directly from my, okay. You want to respond to that?
But the wildfire, if we have a very dry summer, there's usually less wildfire. During 2015, 16, there were less wildfires in my mistaken by our winter. Because the northeast half of the country was much drier during that summer. So usually during coming years, we will see less wildfires than during coming. During La Nina, we see more wildfires in the Western Cape in the summer. Usually they have more wind.
Yeah. So I'll just repeat that question and answer. So the question was really about wildfires and the relationship. And again, when there's El Nino and when it's drier, less fuel, less fire in the winter, in the summer rainfall area. In La Nina, generally more fire in the Western Cape and in the winters of the summer rainfall areas, because there's more fuel that grows in the wetter seasons. So there's a relationship. And I still like to argue that wind, extreme wind, is a factor. And I think that we need to look at wind in the Western Cape in relation to La Nina. Still think there's a relationship there. And that matters because of both mountain fires, wildfires, and shack fires, which get fueled by these huge southeasters that come through when it's raining and in the north. Yeah.
All right.
Good.
I'm just gonna take just one last hand and then we'll wrap it up. Can go on.
My name is Kajan. I just wanted to learn maybe exits in your I haven't heard anyone mentioning climate change attribution with regards to the intensity of the comment on that would be appreciated.
In my talk, immediately following lunch, and I want to have the topic.
All right.
Gonna get there.
It's
the bottom.
It's fine.
Never.
Again, we'll talk about the Paris Agreement when we talk about the climate change connection.
All right.
Okay. Katlego, thank you very much.
For lunch.
Thank you. We're going to break now for lunch. It should be, oops. Let's see, lunch is 12:30. Yeah, we are going to reassemble here at 1:30. 1:30. 1:30. We're going to reassemble here at 1:30. Lunch should be ready for you. Okay. 1:30, everybody. Thank you. I'm going to pause recording. Pause recording. Hello, everybody. We are due to start again shortly. Right. Ladies and gentle people. It's 13:30. I think we're going to start up again. We're going to start up again. So what we have left on the program for today are the following things. I'm assuming I'm sharing the screen. Let me double check. Stop share. Share screen, screen 2. Okay. All right, so what we're going to do today, this afternoon, are 2 or 3 things really. So what we've done this morning is give you as much information as we have about what the ENSO is, what the impacts of El Nino have been, and in particular 2015-16. For this section here, we're going to look forward now in 2 ways. First, Professor Landman will give us some input on what we know about this coming event and some information about it. And then afterwards, Declan will talk about the National Disaster Management Center and how it's structured and how it will interact with some of these potential events and how they've worked in the past. So we'll do that now, and without further ado, I will stop sharing that and I will put up this talk here, and then I shall share the screen again. So to do that, I'm going to share screen 2. All right. How's that? Yeah, I think it's sharing. I think we're good to go. Okay. Thank you.
Yeah, thank you for coming back after the very nice lunch we had. So this talk will be about making forecasts. And so the focus will be on primarily on the forecasts of ENSO that we produce in this department. I'll also show forecasts produced by other centers. I'll have 1 slide as promised about climate change. Then I'm going to end off by showing a rainfall forecast for spring. And let's see what we can get from those forecasts. Okay, so this is a forecast for this season. Before we get to making any forecasts, and this is sometimes something that we as modelers forget, we are oftentimes too interested in what the forecast shows as opposed to what the hell is going on at the moment. So if the event that we are predicting is not yet happening, then surely there must be something wrong with our models. So this is why we really need to check first if there is an actual event happening. So what we see here, again, it's just a reference to the Nino 3.4 magical area that we are most interested in. It's over there. So it's about there. Here is the sea temperature map. So that's the full map. And like I said before, when you see areas of sea temperatures as warm as this, it's hard to imagine that the temperatures there are in excess of 30 degrees Celsius. So when we had the very strong El Nino of 97, 98, for example, the temperatures were 32 plus degrees. It's amazing to think that seawater can become as warm as that. It's really warm. So what we see at the moment, this is for a period centered around 7th of June, so very recent. You see already a warming of sea temperatures in excess of 1 degree Celsius. Here we see also sea temperature anomalies for the different boxes as we see here. And again, we'd like to look particularly at the Nino 3.4 box. This period here is associated with the La Nina events that we experienced. We had 3 consecutive events like that. Following the warming, you can see there's a clear warming trend in the observations. Okay, so this is great. We see that now we are experiencing a warming. So we also see this in the time series of the Nino 3.4. Oh, okay. Right, okay. Here's the sea temperature anomalies. So anomalies are deviation from a long-term average. You see the 3 consecutive La Nina events, and we're starting to see evidence of an El Nino event developing. So the observations are showing this warming. But can we predict this? And this is what this talk is mostly about. And it's no use just showing a forecast. We always have to, in association with the forecast, give some indication of how good we have been making forecasts in the past. And so the next slide is supposed to do exactly that. This is again predicting the sea temperatures in that magical Nino 3.4 box. The thick black line shows the observed anomalies, and these thinner lines shows forecasts made at lead times up to 6 months back. This is specifically for the month of January, when you see that Enzo is in its most mature phase. Is there a problem?
The problem was that I didn't record you from the beginning.
Okay.
You have to start again. Okay.
You can see there's a very close relationship. I look at those correlations. This is a Spearman. It's a type of a correlation, but with rank values. And here's just a mean square error skill score, some skill estimate that we used to calculate forecast performance. With, like I said, with lead times up to 6 months. So it's a very long lead, showing actually quite good skill. This skill, in terms of sea temperatures, are mostly restricted to the equatorial areas. So when we see the mid-latitude areas like over here and over there, where we see blue, the blue means the forecast skill is negative. It doesn't mean that when we predict above normal sea temperatures that we should expect below normal. It just actually means the forecasts don't work. Okay. So the sea temperature predictions.
I never. We can't hear.
Okay.
A thing.
I'm not sure why you can't hear. Can you hear me
Can
talking?
you also speak to us? We can't hear a thing.
Okay. Can you hear me talking now?
We can't hear the Prof. We can't hear him.
Yes. Can you hear me talking?
Yes,
now?
I can.
Yes.
Can you talk to it instead of the board? Okay. Okay.
It's an AI.
Okay.
Treat it with respect.
This is going to be easy. Okay. So I'm re-emphasizing again the fact that we are very good in predicting Nino 3.4 SSC, but as far as global sea temperatures go, we have our skill mostly restricted to the tropical areas. This is a forecast that we have produced for the 97-98 event, and this again just shows not only scores, correlation, what have you, the actual capability of predicting this very strong event during 97-98, even getting the anomalies right. So this slide should convince you that we can do it. Okay, the next slide shows the forecast for global sea temperatures produced in January. So if you look at my forecast product on the university website, you'll see these maps. The IC stands for the initial condition. So that means the month in which the forecast was made. Then we have the seasons. This is, for example, January, February, March, and this is June, July, August. So by as early as January, we started to make forecasts for this period in which we are in now, for the sea temperatures to be anomalously warm. Are anomalies.
Somebody is not muted. Just mute whoever it is that's not muted. It's Peter, I think. Okay, just muted. Okay.
And so if you think back about 2 slides ago, we showed these anomalies already present. And so the forecast that we produced in January is correct. We've got those anomalies. Okay. So you see the observations actually happening. Sorry, the forecast actually working out. So the next one is just the forecast produced in the next month. And this is a forecast produced in February. And we see again, as we head into spring, that the sea temperature anomalies over this magical area is predicted to be on the increase. And then I'm just flipping through the other 2 quickly. And you see this is a forecast produced in April, showing clear indication that there's going to be an El Nino event. So from quite early on, we were able to say there's an El Nino coming. Now, these 2 are the most recent ones, and I'm putting them here for a specific reason. These are again the forecasts, but for this was in May, and this was the most recent one produced in June. And I'd like to bring your attention to this anomaly field over here and comparing it to over here, which is also manifested in the forecasts produced for the Nino 3.4 area in particular. So here again, we have different seasons. These are the sea temperature anomalies, and with the intensity of the different phases of Enzo and La Nina and El Nino events. And last month, we said, according to our forecast models, that this event may be strong to very strong. However, the latest forecast, the one that we actually produced last week, showed moderate to strong. So this doesn't say that the forecast models are not useful. This is an illustration of the uncertainties associated with even forecasts for El Nino. I've mentioned this before, that on the seasonal timescale, the most predictable phenomenon on the planet is Enzo. And even with Enzo, there's uncertainty associated with the forecast. And what these 3 lines represent, this thick red line is a kind of an average over the models, and the thinner lines on either side of it is supposed to give you some indication of the uncertainty. But we have to realize that at this time scale, even with the prediction of Enzo, we have to do it probabilistically. We have to be able to give to the user the range of possible outcomes. Here's an illustration of the forecast produced by one of the most advanced seasonal forecast models produced by the European Center for Medium Range Weather Forecasting, ECMWF. What these dots represent are similar to the IC on my maps, the initial condition, the month in which the forecast was initialized. You can see the black line representing the observed anomaly. This is for the Nino 3 areas. And you see the different forecast plumes. You see there's a range of forecasts indicating the range of possible anomalies. But these forecasts don't go the opposite direction. You know, it's not like one is predicting a La Nina and the other one is predicting El Nino. It's nothing like that. Once this particular phenomenal event gets going, the forecasts continue to give you a range of possible strengths. In this particular case, it was actually overestimating, it was overshooting the actual observed anomaly. And here we see something of models weren't too sure whether or not this is actually going to die out. You see, so even with this most predictable phenomena on the planet, there are uncertainties associated with that. So when it comes to the prediction of things that are a consequence of this, obviously there's going to be a lot more uncertainty associated with that. That's why we cannot, we shouldn't ever make forecasts of a deterministic nature on this timescale. So here is my probabilistic ENSO forecast. This was the one produced in January. The blue bars represent the probability of a La Nina event. The yellow represent the probabilities associated with an El Nino event. And the green represent probabilities associated with the ENSO neutral event. And this was predicting the demise of the then current La Nina state. This is the next month's forecast. You see that it's significantly increasing the probability of El Nino. And by the time we got to May, it gave the resurgence of another La Nina event a very small chance, 5%. Effectively, that means 0%. And now we see the forecast produced last week. And this is for a period ending in November, December, January, giving very small probabilities associated with La Nina returning and very strong probabilities of an El Nino event manifesting itself. Now, this is just our model. Our model consists of the combination of various models, including output from global climate models and statistical models combined into one output. But let's see what forecasts from other centers may look like. And I always encourage you to make use of more than one source. We'll talk about where do we find these things. I know my effort, my effort, and my students' efforts in trying to produce seasonal forecasts. We see this as supplementing the forecasts from the weather service, because they are the authoritative voice making these forecasts, and we believe that our forecasts are supplementing them. So look at their forecast, look at the forecast from other centers like IRI, for example, and in addition to my forecast, if you care to look at my forecast. Here is the forecast plume produced by the International Research Institute for Climate and Society, based on the number of models. Now, in order for your model to be included in this plume, it has to meet certain criteria. And the one that's labeled CSIR IMM is ours. So ours is participating in this plume. That's why we can believe it. No. But this also shows, if you look at the average from all the climate models, the average from statistical models, is definitely showing except for this crazy one over here, very small chance of La Nina making a return. So if you combine these forecasts into a bar chart like this, it shows significantly increased probabilities of an El Nino event with negligible probabilities associated with La Nina and relatively small probabilities associated with ENSO neutral. So there seems to be a very strong statement coming from us, from other places, that El Nino is here. It's there. We see it in observations. We see that our models that we used to predict early on during this year were able to pick up on that anomaly, that positive sea surface temperature anomaly. So there's very little doubt that we are headed towards an El Nino season. I don't think we have any doubt about that. We may have some doubt about how strong it will be. Like I've said, like I've shown in 2 slides ago, that the forecast that I produced last month compared to this month, with using exactly the same systems, is slightly different. So we need to be cognizant of the fact that the intensity or the strength is not yet something that we are very certain about. Now, for the slide that most of you apparently have come to this to the summit, talk about climate change. Okay, so these are 2 papers produced a few years ago, and they asked the question: what will happen to El Nino and La Nina in the future climate? Now, this is a projection with low mitigation. I call it the Trump scenario. where we dig coal. So this is like the worst case scenario. Okay, so if we are allowed to continue as we are without taking cognizance of the Paris Agreement, and by the Paris Agreement, for me, it is about whether or not Lionel Messi will play for PSG next year. So there's another one. It's a secondary. Okay, so is to summarize a very important finding from this paper. Climate modeling evidence, this is for low mitigation, for a doubling in the occurrence in future El Nino events. So it's going to be twice as many as we see now. What about La Nina? We also see a doubling, and 75% of those are associated with La Nina events immediately following an El Nino. So we may be experiencing a season of no or little rain, resulting into crop failures, followed by a fantastic rainfall season causing crop failures because of too much rain. So that's a problem. So on average, maybe the rainfall signal is not very strong. Maybe we're going to see the rainfall not changing much. And then it comes back to that temperature issue that we talked about before. And Johan showed something interesting. And he's talked that how that particular season in 2015-16 was associated with these extreme temperature events. And some work that Johan, published work that Johan was also involved in, we found that when you look at crop yields, it's not necessarily the rain that's going to have much impact in the future climate, again with low mitigation on crop yields, but the temperatures. If temperatures are allowed to continue as they are under low mitigation, which could mean like 4 degrees Celsius warmer than we are seeing now, it can rain as much as we want, but the crops will just get scorched. So the temperature issue may become a much bigger consideration than the rainfall issue in the future climate. But these temperature fluctuations are also strongly linked to ENSA. But this knowledge of what happens during ENSA and whether or not we can predict it is a type of adaptation strategy that we believe can help us. It may be helpful to know whether or not we're going to die in a few months' time, I suppose. But now, before I get to my slide that shows my summary conclusions, I'm sticking my neck out to make a forecast. On the left, you see the typical forecast product that we see on the University of Pretoria website. So we see probabilistic forecast of wet conditions, the blue, and probabilistic forecast for dry conditions, the red and orange. For this season of September, October, November, that's typically spring, as issued in June. And I've alluded to this before. When you make a forecast, you have to give some indication of how this particular forecasting system has been successful in the past. And so we assign particular scores to the forecasts. And it's actually a nice paper that we just, it's in press now, how we relate these probabilistic scores, which tells us something about the model's discrimination capabilities, to ordinary correlations. Read that paper. So we provide, along with the forecast, an estimate of the model skill. So what it says is the rain that we've experienced in the Cape will stop. We're going to see maybe a high increased likelihood of a dry spring over there. I should just quickly mention here that 2 months back, or 2 forecast cycles back, we actually predicted a dry winter. Then after that, the forecast swapped 180 degrees around. I thought, oh my, what's going on? Because we were expecting drought, and now the forecast models are showing wet. It's supposed to be in here. Yeah, I don't know. Showing wet. And the same happened this year. So can we claim success? I don't know, because there was no way that we actually anticipated this, the flooding. We said there's an increased likelihood of it being wetter than normal, but there's no way that we could actually have captured this, the immensity of this event. So that again and pose the question, is the seasonal forecast then useful if you cannot actually capture these really extreme? In this Southwestern Cape situation, we couldn't, although we did see the direction better. The extent of it definitely wasn't captured. But anyway, so this is the forecast for SON, and then the same systems a little bit beyond the period for which we are currently making forecasts for, a little bit beyond the period for which I personally feel comfortable making forecasts for, and it's showing again a wet spring. This sometimes happens in El Nino. And it's actually got a term, it's sometimes called a false start. You see, sometimes when there's an El Nino, we have a wet spring. And then people think, it's fog. It's been raining, I don't know what the hell they're talking about. And then it becomes dry. So we have to carefully look at the forecast because we don't know yet with confidence what might happen in midsummer. The forecast for spring is not as skillful as the forecast for midsummer. So there's a little bit of doubt about these forecasts already, but at the moment it shows there's a chance that we might have a reasonably good start. What does the IRI say? IRI says Western Cape will be dry, and if you look carefully, there's one or two little split points that shows above normal. So they maybe they see the same signal. Some indication of the fact that we may not have a terrible spring, but nobody really should be at this point in time be sticking their necks out about what the main summer season is doing. Okay, so to conclude, this is my summary slide. Central Pacific Ocean SSD is warming. See evidence of that in the observations. We have good skill in predicting this. We have actually been doing this at a dangerously long lead time, 6 months ahead. We have uncertainties because the demonstration I showed you the intensity of the event. When I looked at the forecast from other centers, they all show El Nino. There's a doubling of those events possible in the future climate. And I concluded by showing actual rainfall forecast because we don't live in the Pacific Ocean. We don't live in one of those islands. We live in Southern Africa, and we'd like to actually see how the ENSO is impacting on us. So this was the first trying to say what this coming season might be like. And at this stage, we are, I think, to go beyond spring is a bit irresponsible. But at the moment, it says spring looks favorable. Thank you.
Thanks. I'll just again, I want to just interview Willem just to make sure that I understand it well enough. Just to start at the end with climate change, what's really important to understand is that winter and summer still occurs in climate change scenarios. The question is, what kind of winter, what kind of summer, and how our summer is going to change, how our winter is going to change. So that's an important consideration. And what these models are saying is that the frequency of ENSO, both extremes, the variability then changes. So if you think of ENSO as a sort of a sloshing between these states, is that right? You got a El Nino state, a La Nina state, that's sort of flowing like a pendulum. Sometimes it stays in one area for longer and then it moves to another. That the frequency of these changes might change. That's what they really say. Okay, so we're going.
That's a low mitigation.
That's at a low mitigation.
So
Okay.
That is if you don't do anything.
Yeah. Okay. So that's important. Don't go away. I'm not finished yet. Then, but what's important, so what I want to also understand is that your confidence in predicting the existence of an El Nino is not correlated with the strength of that El Nino, is it?
Well, the example I showed there is the fact that we made an error already because 2 months ago we predicted a very strong event. And just a couple of weeks later, the forecast is for a medium to strong event.
Right.
If you look at those forecast plumes for 97, 98 event, they all show the same direction, warming, but the spread associated with the intensity, the strength was quite significant. As we got to the turning point, it was a bit more certain, although it did overshoot again.
Okay.
Forecast showed that it was actually warmer than was actually observed.
Okay.
My point is, we may have some doubt about its strength, but at this point, we don't see going the other way. All of a sudden, back to La Nina.
Right. So we are confident we're getting the El Nino. In fact, I think we are in the point now where the most press is saying we are in El Nino, right? In El Nino event. The impact we will feel more in the summer, our summer. I guess the impact in the northern hemisphere will be more sooner. I mean, in June, July, August, right? They'll feel it then.
So Enzo has his biggest impact during the DJF season. So they're winter.
They winter.
Our summer.
Okay. Okay, cool. Then the final point is that the strength of the El Nino, as we saw this morning from our other colleagues as well, isn't directly correlated to the strength of the impact. So ENSO in itself is not an extreme event. Even an extreme ENSO is not the extreme event. It's the cumulative manifestation of that ENSO on our climate that produces the droughts, the fires, the heat. That's important.
And also what is important for the impact of this event is what happened last season.
Right.
We've talked about that with Johan's presentation as well. So this season, with all the dams being full.
Okay, so
maybe less.
Okay, good. So that means that basically what we know and we can be confident about is that there is an El Nino. It looks like it's developing into a strong one, but we're not certain. It's too early to tell its trajectory, and it's too early to know what its impact might be. And that this is where we're at currently. Okay, thank you very much.
That's why you need to follow the updates and the forecasts.
Which we will. Okay. Let me just check if there are any burning questions. I see a lot of comments and questions online. Willem, is it possible to do a comparison between SARCOF and IRI? What else have we got here? Question for Willem. I'd like to hear Willem's thoughts on current forecast reliability for Africa when considering we are in unprecedented state of the warmest global ocean on record. I think that's a worthy question to look at. That's from Bruce. So earlier this morning when I introduced, I showed you that sea surface temperatures are at an all-time high. What would that's saying our baseline for an event? Like if we see, is that really just a reflection of El Nino signal, do you think? What does it mean?
Well, the fact that we have warming temperatures, I don't think that's El Nino. I think that's anthropogenic. It's us.
So Willem is saying, you better say it here, but I also have to. Willem said, well, that's mostly an anthropogenic signal. And El Nino is contributing to that. So that's why we're seeing that. So it's a cumulative effect, really. And I think I try to show that Bruce, if that's Bruce Hewitson, I'm not sure. I showed those very images this morning from the climate reanalyzer. I think the question is really, will it affect the reliability of forecasts if there's another signal interfering, so to speak?
The reliability of ENSO forecasts, I don't think would be much affected. The reliability with what happens with rainfall might be affected because if we see a continuation of the warming temperatures in the Indian Ocean, that's also supposed to have an impact, even if it's just there to supply the moisture for the reaching highs that bring moisture into the region, that may definitely have an impact. But to what extent it would be is very hard to say. One of the problems with this enterprise of trying to predict the season ahead is we know we have verification statistics based on past forecasts. We do not know if the climate that's about to happen will be represented by any of those years.
Right.
That we have actually verified the forecast of.
Right.
We hope that it is.
Yeah. That's because it's such a dynamic system, right? And I think the important point here, and this does speak to the Paris Agreement question, right, is really if systems are changing, then it changes the way in which models interpret the system. So I think it's basically we're just making it more busy, more complex, more difficult, and keeping us employed, right? That's really what it's doing, because it's just so enormously complex. I feel like I need to answer your question because you asked it 3 times about the relationship with the with the Paris Agreement. Well, the answer is I don't know. But I think you have a point of view on that. We have an audience member who has a point of view. I'm going to try and relay what you said. Yeah. Debbie from DFFE. Right.
Even mitigate the climate change adaptations to ensure that you comply to the negotiation with your agreements with the Paris Agreement. Remember, South Africa is significant to the table. So we've already said, we promised that we will keep our temperatures below X. Okay, now with this modeling, you can see what sort of temperature change.
I see your point. Right.
That's what the Paris Agreement is. That's when you climate change adaptation modeling and recommendations will come in so that we can comply to what we promised.
Right. So the point is that we have commitments to. Now, I don't know if we have commitments to temperature or commitments to emissions, which I think. Okay, so the question is, if our temperatures go up as a consequence of ENSO, what implication does this have? And what can we do about it? So, okay, I understand your concern related to the Paris Agreement. I mean, I think, you know, the role of ENSO in the whole climate story, not just for South Africa. Yeah. Right.
Doing this research.
Right.
And you put them all together, have a really good model on how to actually attack everything from climate change to, well, you know,
So Debbie, it is right, is making connections between these various different components of the climate battle, so to speak. So thank you for that, and I think you should take the lead. It's your responsibility. You're at DFFE. Thank you, Debbie. I need to move on. There are some more questions for Willem. We do have a question, a broader question and answer session. We'll go to the Padlet as well. Sorry, there is one more. Okay, let me take one more at the back, please.
Hi, my name is Jerry. The question for Willem is, there's a school part in the economy that says, with climate change, and therefore failure of better mechanisms, the likelihood of this signal continuing with the is diminished. And therefore, if it diminishes, means the whole conversation that we had there was one. They moved, but where?
So let me just repeat the question and then you have to come give the answer. So the idea is that there's a school of thought that says that this becomes, is it effectively permanent? Is that the point you're making?
Well, the signal disappeared because of the change.
Okay, yes, because of the changing baseline, it gets drowned out effectively by the background noise, the anthropogenic noise. And so you can't see the ENSO anymore because it's, you know, it's ambient effectively.
Yes. So I was asking a question by asking a question, from when on would they see that? Is it over the next 6 years? 6 is very important for me because in 6 years' time I retire, then I have to worry about it. Or is it in 20 years, 30 years from now? Is it now already?
No, it's not now already, but basically it says, I think in the next 2 decades. But remember the magic number is 2030 only. And so there's that question about that. But it leads me to a second question, which is the conversation that we've had so far this morning from different experts seems to suggest, one, that South Africa does not have a multi-asset system, but multiple systems. And in a sense, the research unit here as a component of that in your talks. and the model and the prediction that we offer every year. Is how then does the average person in the street access all of this complex information in a way that they can digest and make risk assessments for themselves
Right.
as to what to do next.
Yeah. So Jerry, can you repeat the question? So what the question is really that the conversation we've had today shows that there are different sectors or different kinds of concerns, different kinds of inputs. The question is, do we have a multi-hazard early warning system, which can then be usable by a range of different people and integrate information in such a way that it produces that kind of multi-hazard information?
Yeah.
Do you want to answer that? I want to comment on that, and then we have to move on.
So
Okay.
on this seasonal timescale, I think it makes sense to look at the authoritative voice in the region. Who is supposed to be by law making these forecasts? And that's the Weather Service. And so if our forecasts are completely in contrast to what they say, then obviously you have to use their forecast, I suppose. But in the situation that we are finding ourselves in, this effort here is supplementing their effort. So we like to point users to the Weather Service as the authority on this timescale. So if you want to have one statement, I think you should look at the statement that the Weather Service issues. Presumably, people like us at the University of Pretoria can contribute to that statement. But I think it makes sense to have one voice saying about what the season ahead might be like.
I want to add to that comment. What Willem is talking about is one source of information about the climate forecast. A multi-hazard forecast is a much more complex animal, and that takes that information much further down the track towards sectoral application. And I have been involved, and some of my colleagues here have been involved in a project to help develop what's called the National Framework for Climate Services. Now, I don't think that's exactly the same thing as a multi-hazard system, but they certainly are kind of correlated or related to each other, which is a system whereby you go to individual sectors like the health sector, the transport sector, agriculture, etc., etc. There are, in fact, 8 identified. And you ask you workshop with those sectors, what do you need to know? Because as a climate scientist, I don't know what a malaria expert needs to know. And the malaria expert doesn't know necessarily what kind of climate information can be offered that might be of use to them. So there's a sort of a discovery process that's developed. And if you can get that right for all sectors, then you can trace it all the way back to what observations we need to be making, what kinds of interpretations and modeling needs to be done, at what time scales, and what space scales. So what do we need to do? What months are important for this particular sector? Onset of rainfall, amount of rainfall, intensity of rainfall, and other parameters, for example. And so you develop a complex but useful system of information flow from observations to applications. The multi-hazard system is part of that. When there is, as you say now, there's a tropical storm coming along the coast, who does it affect? Where does it affect them? When does it affect them? And in particular, so I think there's huge scope for that. And I think there is process underway to try and get that right. Thank you. I'm going to stop then, segue, to use a phrase I can't stand, into our final input from us today. Where's Declan? Oh, there you are. So Declan is from the National, I don't know, it's NMDC, and I can never remember what it stands for. NDMC. I probably got that wrong my whole life. And I'm going to find your presentations for you. I'm going to close that one. I'm going to open. And really, we asked Declan to participate in this event just to give us an idea of how. There's one here. And which one do you want? There's this one. Was there a second one? Can you say this one? Okay. Where's that? Put that up. Okay. So now that's there. Now I just have to share it. Stop share and okay. All right. So Declan is going to talk to you a little bit about NDMC, how it works, what it does in dealing with extreme events.
So good afternoon, everybody. We're going to move away slightly from the very scientific, graphic oriented presentation that you had before. So basically, I'm going to bore you to death, telling you about the NDMC, but also maybe just explain exactly why we are so interested in rainfall variability created through these systems. So I noticed also that the presentations are not forming the normal overview and stuff. So I'm going to skip some of the slides and speak to some of the issues at a high level. You probably will get the slides, but I also don't want to go through it slide by slide. It's not.
You have to click on this little arrow here. That one.
So basically, just a rundown of the function from a disaster management perspective, why we're interested in climate systems from a disaster management perspective, and why we have these long-standing relationships with institutions like the ARC, South African Weather Services, and some of the universities, and give you an indication of our work in drought and how we manage to get more insights around the ENSO phenomena as it is. So just basically at a very high level, the Disaster Management Center, it's a program within local government. It sits within cooperative governance. It obviously coordinates disaster management in the country through a legislative and a framework perspective. And we have several functions really around this kind of forum, creating institutional arrangements where we administer the function of disaster management. And we are focused on the proactive disaster risk reduction implementation in the country. And not all of that is successful all the time because of the magnitude and the scale of disasters that we have, not only in the region, but also in South Africa. And also this increasing vulnerability and changing hazard perspective, as we've just heard from our previous presenters. We are very much focused through the grant system on recovery and disaster response, especially in the different regions. So we have a winter and summer rainfall focus. And we are also really about communication and sharing the knowledge, creating and generating new knowledge, especially because the disaster management fraternity consists of multi-skilled and multi-competent levels of disaster management function. So what you find at the National Center compared to what you find at the districts and local municipalities can be really varied. So in terms of the policy framework and how the model works is that each disaster management center, whether it's located at province, district, or local, has these sort of key performance areas. It's mainly really aligned to the act and how the legislation of disaster management is. But within that, there's various ranges of governance, various ranges of leadership, and various ranges of implementation. So if you take this as a map of how the function is supposed to be, then you'll understand that these are the core areas within a disaster management function in a country like South Africa. So institutional capacity at all levels, which means at a local level, you need to have the skills, competencies, and obviously the means to create some kind of capacity at a local level. Risk assessment, especially when we're looking at products like, the topic of discussion that we've had today, but also other things, other risks not related to natural hazards. A very keen focus on risk reduction through a very proactive sort of measures on the ground, and the three enablers sort of undergird the function at any level. So just basically, we also oversee the fire legislation, and this is just a summary slide of how that process takes place in the country from a legislative process. So the legislation gives us what we're supposed to do. and the framework guides us on how to do it. And we then cascade that down to the local disaster management centers so that the national center doesn't become a response for all kind of entity in the country. Just basically how, where this kind of information that we've heard this morning feeds into, mainly at a political structure and a national advisory structure where it's more sector based. So the discussions that we've heard this morning around, what would the impact of drought be on local farmers, on subsistence farmers? That's where we focus in terms of the right-hand side of the discussion. So it's more very collaborative, multi-scaled effort through the country through a governance process. In terms of the funding arrangements, this is just a summary slide. 2 grants get administered, one for immediate relief within the 3-month period, and one for specific reconstruction and rehabilitation. If we are focusing on the topic of the day, we want to understand exactly what the rehabilitation is. And through a drought hazard or a drought occurrence in the country, those rehabilitations are through programs like the land care, subsistence farming, the declaration in provinces to unlock some of the funding from national government. Just from a weather pattern perspective and the topic of early warnings for multi-hazard, just looking at the country as a whole, we know that we face mainly this hazard focus from severe weather. Much of our disasters are really caused by severe weather. If we look at where these incidents are recorded on your right-hand side, you can see that the summer rainfall areas predominantly sort of dominate that occurrence over the country. So we're interested in both quick onset like flooding and hailstorms and windstorms, but also very much focused over the recent years on slow onset like an impending drought. And that's why the topic of El Nino becomes really important for us to focus on, to understand what's happening, to understand the predictions, to understand the range of variability in that prediction, and to obviously take the process forward. Just touching on what the last presenter said, it's very important to also understand those 2 concepts. How long will the phenomenon go for in terms of multiple years? Because that's obviously the drain on the national fiscus from a multi-year drought, and what happens before that actual drought takes place. How much of rainfall, what's our surface water conditions, what's our regional flow in terms of food security, and so forth. So there was a specific report in 2016, and we had studied drought a couple of years before that, but it gave us a policy change in terms of our focus. We had to incorporate these kind of different risk reduction measures. We had to adopt a more active, proactive stance, but we also had to look at research, filling out the gaps, and understanding the eco-DRR kind of perspective from a country. If we looked at the international studies for South Africa, we can see slow
Somebody is not muted. Hold on.
Slow onset disasters like drought have a real long-term pressurizing effect.
Gaan jy nou weer bel, André?
André, jy moet mute asseblief. Jy weet nou nie wie is dit nie. Why can't I see all the participants here? Here they all are. Is it Marshall? Marshall Madoka was unmuted. Okay. Beers for everybody. Sorry. Carry on.
No, it's not me.
It's not you. Okay. Whoever it is must mute.
Apology accepted. So just mainly this graph just showing you we must not sort of discard this concept of high impact of drought. So rainfall variability over the region has multiple long-term effects from a fiscus point of view and the number of people point of view, and I will explain that in some of the points I'll make later on. So in terms of Dr. Johan is here, and he'll be very glad to tell you more about their work with us over 2014 to 2016. We actually finished it before the 2015 mid-year drought started, and how we looked at the drought drought as a hazard in South Africa, where it would be, what are the historical patterns, and we focused on just the variability of rainfall at subcatchment level. And the point here is that although we looked at rainfall variability, we also looked at some of the factors. The ENSO was one of the 3 factors that led to some of these areas being in drought over multiple time scale in terms of long-term variability. But our target was to get to a drought hazard map with multiple year rain indices. And we wanted to understand that from where we would have a normal picture of what drought would look like in the country compared to those very extreme aspects. And if you get the slide, you'll be able to see just what the components of the hazard focus was. We looked at those particular parameters: frequency, intensity, magnitude, and how regular was the drought? Was it happening? Was rainfall variability the same over multiple seasons? Why do we need to understand that from a disaster management perspective? Because we need to have a visual, spatial view, as in your left-hand side. We need to combine that with our colleagues from the South African Weather Services and their seasonal outlook going into the forthcoming seasons. So we produce a seasonal profile that has some of these factors in it. And then we get the provinces and the country ready at local government level and district level to respond to the impending hazard in the forthcoming season. And that's what's crucial about us understanding and being in partnership with entities like South African Weather Services and ARC, so that we can understand that single true voice going into the next season. On a monthly basis, we monitor this, and this is coming back to the discussion that we had from the last presenter, what's actually happening in the previous season before we move into the next season. You'll notice that we monitor drought every month, and we produce a monthly report. Our baseline is actually a 3-month kind of forecast. So we look at 3 months before, and we map which areas are deteriorating, which areas are remaining the same, and which areas are improving. If you look at December to February 2023, you'll notice that if you think that it wasn't very dry in the Western Cape, you'll obviously, can I use it? Yes. You'll notice the Western Cape and that the West Coast and the Eastern Cape were already in drought periods in December. That started to become more elevated in January, and as the February month and March month took place, these signals have become lower, but the interior of the country coming out of December to February has increased in terms of its wetness. So that's a good sign for us to go into the next season, but it also depends on how long we could have that unsure climate variability from a rainfall perspective. So I also just want to just give you some of my notes from the morning's to until now discussion, just to give you some of our learning from a disaster management perspective. So the first point is during the 2015-16 drought period and our studies after that, after the 3 years, we found that there's this concept of regionality of food from a food security perspective. We looked at the transfer of food between the regions, summer and winter, rainfall areas in that 2015 to 2017-18 drought. And we found that there was quite a bit of shift in terms of food commodities between the 2 different rain seasons from a commodity perspective. So what was grown in the winter rainfall seasons was very different to what was grown in the summer rainfall, and that helped mitigate some of the food security issues for that period. One of the speakers this morning spoke about the food security issues, and we looked at that from a small-scale farmer perspective. The small-scale farmer suffers 2 scenarios. In a drought season, he has to be able to afford purchasing of food in the open market or producing his own. Now, in any drought situation, you know that the latter part of that scenario is going to be impacted. And obviously, because he's purchasing at a higher price with the current conditions, he's definitely in a worse off position as compared to if he can produce it himself. So therefore, drought has multiple layered effects in terms of the community. If you look at the government program in drought periods, they are distributed to severely affected communities, which means that there's always opportunity costs there for not everybody to receive the same amount of help. So that's important to note. Disaster declarations at a provincial level take a long time because of the processes that the province has to follow. So if you're looking at a 3-month period or a 6-month period in which you have to mitigate against that hazard, you obviously are found wanting from a time perspective. So when government funds through a declaration, some of the programs that are normally funded from government, such as the land care and agriculture, have to sustain themselves on lower funding regimes because most of the funding is going to other programs. So these are the policy issues and these are the governance funding issues in a country when you have a drought sort of scenario or we move into this elongated drought period. Also, global current perspectives impact the country. When you have to buy food on an open market as compared to producing it in terms of your country, there's various production issues. The speaker this morning also spoke about the farmers' cattle situation. In the 2015, 2017, 18 drought, we saw the following. We saw farmers waiting too long to sell cattle on the open market. And when they actually became viable for sale, they were actually in a worse off condition. So the condition dictated that they receive a lower price. And because of the uncertainty in terms of how long the drought will continue, farmers sold very late after some of their cattle had already, not managed the period of drought. If you're looking at the discussion that we were having from this morning, surface water conditions and heat, those are the two areas that we are concentrating on, given everything that the local municipalities have to deal with from an infrastructure repair perspective. You can imagine if we have a prolonged drought and what the effect on that will be. And then last point, the recovery systems at a national level from a financial point of view is as long as the drought continues in terms of the country. So post-drought, the country is still funding drought mitigations. As you can see from these maps, some of our places are still have declarations of drought at a provincial level. Thank you very much.
Thanks. So can I, just to understand clearly, does the NDMC provide money, but not necessarily technical support?
So
for a disaster, for example, for some event.
So not exactly. So the money is reprioritized at a national level and goes to the mainstream national departments within the province. So for rehabilitation of drought, it will go to the national agriculture and then get distributed to provincial level agricultural sectors.
Okay.
And the technical help will come from the province itself through the national system.
Okay.
Yeah. So the NDMC is not a first responder as in responding with capital and financial technical assistance.
Right. So you don't buy food and deliver it, you give money for them to buy food. The authorities on the ground, the local authorities.
So when the money is issued, it must go according to the business plan of the province for that actual particular hazard.
I understand.
So if the local municipality is saying that they want to buy 1,000 tons of hay for the local farmer, we are not going to accept that they just buy 1,000 tons. We're going to say, tell us how it's going to be distributed, who's going to collect it, do you have transport to take it to the rural farmers, and those sorts of things.
Right. Okay, so it's properly management. Good. Any questions for Declan on the floor? There's 8 new messages here. Is there an avenue that we can Better scale information. Does the NDMC assist producers with long-term crops, such as vineyards and orchards? That's a question I guess you can answer. The question is does the NDMC assist producers with long-term crops? So, not quite sure.
No, we don't.
The answer is no.
Yeah, so we work with ARC and agriculture to
I see.
supplement that information, so that can be an avenue for further investigation.
Okay.
Yeah.
Yes.
Go ahead.
Thank you very much. My name is Vincent Bokwaka. I just wanted to know if NDMC has any work that's being done on drought-related system-based adaptation in South Africa, and whether those adaptation interventions are working particularly for drought.
So,
Can I just repeat the question and then the answer? You go ahead. Repeat the question.
so the question is whether the NDMC is doing any work on drought adaptation.
On ecosystem-based adaptation related to drought.
Okay, on ecosystem-based adaptation related to drought. So the answer is not in its full spectrum. We have started, the first iteration of that was in 2016. So the focus is definitely in that ecosystem-based context, but not in drought to its full extent. So yes and no, for example.
Good. There are one or two other points here. What I think I'm going to do with this chat is I'm going to collect all these comments and questions and try and produce a document on those. And then when necessary, I'm going to try and get the various experts to answer them. For example, there's a question about better local scale information. And again, that's part of the whole climate system, climate services, multi-hazard process of getting information. I'll just give you one example. When we were looking at the Durban event, the Durban flood event, we had a guy from the Housing Development Agency who we interviewed, and he said, to me, it wasn't so important. The only thing that was important to him was, where can I put people now, which is safe, which is not going to get washed away. Like, I need to know, where can I take people to in the moment. He needed to know that, as opposed to long-term planning. So there are a whole range of different needs at different timescales, and things like the CSIR's Green Book is an attempt to do that, to look at resources, to look at resilience, to look at threat and risk for multiple different hazards at municipal level. So there are resources, but there is a question of coordinating those resources in a system that really does function efficiently and well.
Yes.
Okay, this one here. Which one? This one.
One above there?
Above that one.
Yeah.
There.
Yeah. How is the impact?
Oh, how is the impact classification or categories determined? Impact classification of what? Who is the final authority between yourselves and source? I think you're talking about, I'm not sure, Marshall, if you mean impact, what you mean by impact classification.
Declaration. The event.
Oh, I see.
Yeah.
So in other words, is this a disaster or not a disaster? Those kinds of things. I don't know the answer to any of that. You might.
Yes. So the short and sweet answer there is that the impact is determined by the ability of that local authority or that district to manage that hazard. And if that hazard is beyond the management at that local level, then that classification becomes that province then declares and classifies that as a disaster.
Okay. I want to move along, so thank you very much.
Thank you.
There's just a question I wanted to discuss. Yes, please. There's just one other item I want to just raise here. So this is Kristen Callison says, discussion centers on 2023 season. Is this the same team, or is there another that is looking at long-term mitigation and adaptation to drought, heat, etc.? such as increasing tree planting. So what you're talking about is adaptation measures in general. And I think there are a lot of people in South Africa working on that. I can say that the CSR team, the Holistic Climate Change team that I belong to, has a range of people looking at various timescales of impact. There's GCI at WITS, there's a whole lot at UP, including this department and other departments who are doing all sorts of both predictive and projection work, climate work, as well as adaptation work. Similarly at UCT, at ARC, at many institutions in the country. The question of coordination does matter, which is why we're kind of building these research alliances so we can really map out what has to be done by whom and how. But I think the concept of climate services is becoming more and more important, because this is the way in which we connect up the real utilization and application of knowledge and information by people who really need to use it as climate starts to bite harder and harder and becomes more important. Okay, for our last activity, I set up a Padlet, which is on the board now, and I'm hoping it's shared. Let me just check that it is shared. Yeah, okay. So I did send out the link to this Padlet, and what I was hoping we could do is, because we've given you a lot of information today, and we've had some conversation, but I really wanted us to try and capture, especially from people on the user side, from people who are part of this meeting, who are in municipalities and are in businesses and in enterprises who are concerned about items. So I've asked 3 questions of you, okay? And those questions, we'll look to see if some have been answered, but if you have that app, the link available, and I'll share it with you, well, you can see it. Actually, if you type padlet.com info and then you write El Nino Summit, it'll come up. I'll show you that in a minute again. Then you could get there and you can do it from your phone here, or if you're online, you can go to the same place. In fact, let me just do that live. I want to just show you that if I write Padlet, there, that's the URL you need to go to. So padlet.com info 24566 / El Nino 2023 Summit. If you type that in, you'll get to this page. Okay, you can do it on your phone and you can do it from anywhere. And I'm going to ask that, well, we'll look and see what there is. I've also asked you to collect any specific questions that you have, and we'll quickly review them. I'll try and do that while we're talking. And then we'll see if there's anybody in the panel or beyond that would like to comment on those. So let's see. Oh, screen sharing has stopped. Hold on. Nobody panic. Don't panic. Okay. So let's see here. Share. I'm trying to. There we go. Okay. So I hope you can all see that. So the first question that we wanted to ask the audience to think about was, what are your specific concerns about the potential impact on your business or on your work or area of responsibility? The second question was, what information do you need, and when and how do you want to receive it? And this is really to get to the point we've had in some of the comments earlier, that people have said, well, where do I go to get information? Willem spoke about looking at different sources. And so we're very keen to understand how people would like to receive information. And then the third question is, well, currently, where do you go? Who do you go to get the weather information that you need? So those are 3 questions we asked. And I want to just see here if we've got some answers, or at least there are 3 here. So in answer to question 1, somebody has written preparedness for droughts, particularly for fire readiness. For my work, preparedness for flood events, so more La Nina than El Nino, is perhaps more pressing than to be ready for floods. Another response is, how has ENSO events impacted the fire season? And I think we did discuss that earlier. I think that's an important one to respond to. And then considering that ENSO is likely to drive wildfires, are wildfire authorities considering this increased risk? So I think there is again a fire warning system at source, but I think that's a real area where I think we can point people in response. Interesting to look at now, just quickly, is what information do you need and when and how do you receive it? So this answer goes beyond ENSO. Predictions for different timescales, coming day, week, month, season, with probabilities and clarity about uncertainties. A website with a map of South Africa where we can choose different types of forecasts to display, and we can click on zones to see local forecast information, text or graph. Indices linked to certain risks, flood, fire, agricultural failure, heat wave would help. Different levels of display that display complexity for different users would be nice. A simple one with icons for temperature and rain, like on TV weather reports. For research work, free online access to all past weather station data, time series from source. Somebody's stoking the fire. Okay, there are a couple of other ones here. And then just quickly as the sample for the last questions, for short-term forecasts, check across various websites. This is what they do, right? What's YR? That's an app, I believe, right? Yeah, windy, AccuWeather, seasonality, source forecasts, etc. Verify sources depending on what I'm looking for. Source and YR.no for short-term forecasts, IRI for seasonal. Okay, so really this was just to collect from people participating in this event their thoughts, and we want to collate that information so that we can respond to it in the next event, which we will have as a follow-up. So I'm just going to stop for a minute and see if there are any specific comments or questions on either these questions or on what I just read out to you. So the floor is open for a little bit while I catch my breath. There's something here from Sue Sayon. Let me just check here. Okay, this is more about how we respond. So any comments or questions about this? From the floor or from online? If you're online, you can put up your hand and I'll even let you speak of the 180 people that are still online. If not, no comments or questions. So please, I'm gonna just finish my sentence and please take over. Please do use this, okay, as an opportunity to give us information that we can use to respond more appropriately, shall we say. You have a question?
Just need to bring everything together. Maybe talk about and also the release for monitoring data. Maybe the like open data that everyone has access to all of the information in one place.
Right. So this was just to repeat the point that it's really an appeal for us to basically get it all together in one place. I mean, the suggestion here of like a sort of a zoomable kind of Google Earth-esque information source would obviously be ideal, where you could go to a region and click on a hazard, look at a risk, define your particular area of interest, etc., would be ideal. That does require a huge amount of not only technical collaboration, but interinstitutional collaboration, which is politically difficult to achieve, as we've learned. But your appeal is really for a centralization of information and open data. Okay, well, I mean, we're not going to open that can of worms today, but I can say this with confidence, that it's not anybody's desire to hold on to data, right? There are ways to get data, and the reason that data is difficult to get to is because of some of the economic models, and there are efforts to try to overcome that problem. But before you get cross with me, I just wanted to say that there are ways to obtain data, but it isn't easily available straightforward in a straightforward method. And I think that is an issue. And one of the design elements of the climate of the climate services framework is in fact a climate systems information system, which is envisaged. So there's hope and desire. Please, it's Kevin, right? Mark, sorry, Mark.
How long will this be left open?
Oh, I can leave it open indefinitely. I'll email everyone to remind them. Yeah, I won't close it. You can add to it. Yeah.
And second, DFFE's statement part of their state of the environment process indicated working delay.
Did you say state of environment?
DFFE.
Oh.
They've got an indicator working.
Right.
It's looking for presentations and input that is supports what is video indicators. How they align to.
Right.
Yes. Something.
Okay. Thank you for that. Just looking online here, if there's anything. There's a question here from Kurt Stock. Generally, if the Cape gets good rain, it means the North are in for a good season, question mark. I don't know. No, I don't think there's any relationship.
So often what you find is that if there's a strong southeasterly wind blowing, it's part of a bigger weather system that can lead to weather favorable the next day, or whether or not there's a link between seasons.
Yeah.
Very weak. Yeah.
One more, please, go ahead.
You mentioned earlier the relationship between winter and the northern hemisphere. So like for instance, now the current summer temperatures negative.
No.
Does that have any correlation to how that will be known?
No, so if it's not that, it's not directly linked. It might be that it's something that that's the common connection. What experience not interrelated
Okay, I can see energy waning in the room, so I'm gonna try to bring it to a close pretty quickly. But what I want to just raise is one question that has been raised, and that is the question of the impact not on South Africa but on Southern Africa and other countries in Southern Africa, up until Central Africa. Can one of our experts maybe say something about the region rather than just South Africa? Who wants to say something? Willem, if you do, you have to come here and say it.
The Enzo signal is very strong and kind of homogeneous, south of about 12 to 15 degrees south. If you look at a country like Malawi, it's split right in the half between a wet El Nino north and a dry El Nino south. So if you look at the whole SADC, it's difficult to make a statement. It's rather more helpful to look at an area where the Enzo signal is homogeneous, like south of 15 south.
Okay, I hope that was a reasonable answer. Just looking for any more comments. Okay, I see that Seon is offering some data on the chat again. I will share that chat with you guys later. Okay, I'm just trying to pick out any other. Wrong one. Yes.
I guess what start off be another form where the dining would be.
I suppose so. I personally am not personally like Sarkov.
This is a question about Sarkov, and I won't repeat the answer. No, there's a variety of points of view. Okay, look, folks, it's 3 o'clock, 5 to 3, and we got a lot of questions which I think we're going to need to process. We're not going to get through them right now. I have to update my computer anyway. It seems it's not giving me any choice. I've delayed it enough. So that's a good signal. So look, I'm going to try just to give a broad overview of where we stand. Today, again, I want to remind you that the effort today was to raise awareness and to really try to educate people about the potential and to start the process of preparedness. What we've told you is that there is an El Nino developing. We've told you that there have been La Ninas. We've told you what the general pattern and relationship between ENSO of different types and weather and impacts on South Africa and Southern Africa. We've told you about what happened in 2015-16, which was a really severe impact event. But we've told you also that our confidence in knowing what kind of impact is going to be is low, especially at this early stage of the process. We hope that we've also looked at what this ENSO is looking like at this early stage, and we are considering really what we should be thinking about and what we should be doing. And I think that's what we wanted to achieve today. And hopefully we started a conversation where we will learn from you what it is that you want to know. And that gives us the task of taking it forward to consider in the next couple of months what things are looking like. And we will call another meeting. We might do it differently. We might make it shorter because we've given all the basic information and we'll allow people to look at that. But we certainly will update you and try and respond to some of these questions. So my undertaking is to sift through the information and the comments that we've got, and then to try to feed that back to you. And I will keep everybody who registered informed of where to find this recording and the responses to all of this stuff. So that's what I have to say. I'm going to just give the floor over to anyone else who has a comment, and particularly from our panelists who remain, Katlego, Christine, Johan, Declan, and Willem, and Peter online. So any comments from our panel at all? Do you want to? Sorry about that.
I was neither pleasantly or unpleasantly surprised about interest on climate change. I thought this focus would be more on the season ahead. But for the next meeting, we certainly have to have a climate change expert. I don't think any of us is really focused on that specific timescale. So I think for the next meeting, we need to have a climate change person also present with something.
Right. I think that the climate change element is something we can bring in. Katlego, anything you want to say? You okay? Christine? Peter, I see your hand. So just to reiterate, her point is that climate monitoring is really critical and that we need to be following forecasts. But I think we also do need to provide the platform to provide that portal to information. Source has incredible resources if you look for them. So you can follow on.
That's all. If developing a multi-early warning system, that would be a one-stop shop for all that.
Okay.
All the hazards. So look out for it. Hope that we'll collaborate more with and other institutions around.
So that's just Katlego emphasizing that Source is busy developing a one-stop shop early warning system, as she called it, right? Yeah. Good. And I want.
Just now putting it in one place.
Okay.
Yeah.
Again, I'm going to ask you just to listen carefully, those in the room, because Peter is going to also make some quick final remark. Peter?
Hi, Neville. Can you hear me?
Yes, we can.
Great. So there's been a lot of hype about this El Nino and a lot of reports internationally about this being a very, very strong El Nino and a record El Nino, and we've seen record sea surface temperatures. And there's also suggestions that on the back of global warming and this El Nino, we are going to see many records broken. And I think it's important for everyone who suspects that they may be vulnerable to actually grapple with that vulnerability and try and find out exactly where their vulnerability is and how exposed they are to this, and then to really work hard in conjunction with those people who've got resources to try and find out what they can do about it, because we really don't want, Southern African famine. We'd really like to preempt that, and early warnings are all very well, but there has to be early response. And I'm really just encouraging people to keep their eyes on this and very carefully, and especially in the longer term as we approach the summer rainfall. Willem has said it's going to rain. That's all very nice, but there are always the what ifs, and we need to look at our vulnerabilities. So that's all I really wanted to say. Thanks.
I'm sure Willem wants to defend that point. He didn't say it's going to lie. He said his one far out model is suggesting a potential false start to the spring season. So again, that is, but I think your point is very important, Peter, is that don't wait for it to happen. That's really the message. We are here to tell you, think about how you are vulnerable. And I actually want to just mention something that Declan taught me, and that risk, as you all probably know, comprises components, and the risks are likelihood and impact. And in fact, that impact itself is unpacked further into your ability to be resilient. And so resilience is really a critical part of reducing risk. So I think that's an important lesson as well. It takes the responsibility on you to identify where you are. Johan, I know Mokele's left, nothing else? Okay. Okay, have I left anybody out? I don't think so. So then it remains for me to thank everybody, especially my contributors and co-conspirators, for contributing, and thank you all for participating. We will keep in touch. We will produce information and communicate what happens next when we have more to say.
Thank you, Nino, for starting.
You're welcome. Thanks, everybody. I think we are done for the day. There are 15 messages, 16 messages. Okay. Oh, yeah, there's still tea and coffee. And any leftovers you must take with you. Thank you, Peter.
Thank you very much.
Oh, can the team just come here? Whoever's left. Katlejo, Johan, and Peter, don't go away. I'm going to put you on full screen so you can be part of the photograph. How's it? Oh, how's it? How are you? I'm good. Nice to see you. Nice to see you. Thanks for coming. Sorry, Katlejo, Willem. Yeah, I can do that. How about this one? This one?
Yeah, that one.
Okay. I need Dan. Declan. Yeah. Christine. Yeah. Okay, wait. I have to hold my computer up here so that you can see Peter. I'll superimpose. Thanks very much. Yes. Thank you. Yes. Thank you. Okay. Can I put Peter on the slide? I need to show Peter's face. Can I put Peter on here? Because he's Cape Town. Okay, hold on, Peter. Don't go away. There. Like that. Okay. And from Kelly's Okay, Peter, you're done. Hold on a second. Thank you very much, Peter.